Good afternoon, good evening, everyone. Let's please observe the following house rules. We are delighted to have you all here, and you're joining us in virtual form to comfort of your own home. Before we dive into exciting content we have in store for you, it's essential that we familiarize ourselves with a few house rules that will help ensure a smooth and enjoyable experience for everyone involved. First, ensure a stable internet connection for a better viewing experience. Next is during our open forum portion, kindly use the chat box. Third, focus attention and please give your full undivided attention while on the webinar. Also, follow the discussion of the speaker. And lastly, practice and observe respectful comments and refrain from using offensive language in the chat box.
Prayer. Heavenly Father, Maker of heaven and earth, we thank you for the Filipino mechanical engineer, for our profession, and for our organization, the PSME. You have sown us as seeds, scattered here and abroad as PSME engineers, humble planners, designers, and builders of all things mechanical, our proud testament to the glory of your creation. We bring before you the fruits of our profession, forged by the fire and burning passion of the PSME mission. Professionalism, to help us maintain the integrity of the engineering profession. Please keep our hearts true to the highest ethical principles of our field. Service, to enable us to contribute to the enhancement of science and technology. We pray for all Filipino mechanical engineers to work together as one in shaping the economic growth of our country. Motivation, to uplift the engineering profession. Please help us promote fellowship and cooperation among all Filipino mechanical engineers and to instill nationalism among PSME members. Excellence, to enable us to become outstanding PSME members. We pray for all Filipino mechanical engineers to actively contribute to the advancement of the profession, to be recognized globally as we develop the talents you have given us. Help us to provide sustainability to the changing world. May the PSME bring together all Filipino mechanical engineers and as one, stand united as beacons of strength and stability to the world. All this we pray through you, our Heavenly Father, forever and ever. Amen.
Sa
PSME Creed. We, the mechanical engineers of the Philippines, conscious of our responsibilities to God, our country, and fellow men, affirming our adherence to the Code of Ethics for Mechanical Engineers, desirous in participating and contributing in the social, economic, and industrial growth of our country, determined to support one organization that shall embrace the mechanical engineering profession, have resolved to unite to accomplish these aims by constituting a national organization of mechanical engineers. PSME core values. I am a person of integrity. I act with honesty, transparency, and accountability. I do the right things the right way. I maintain professionalism at all times with high respect for others, observing proper conduct, following the code of ethics, honoring commitments, and acting fairly and with dignity. I strive for excellence, thereby achieving the highest standard of performance in all my undertakings. I internalize teamwork. I act with sense of urgency, mindful of entrepreneurial spirit, and work with unity, cooperation, collaboration, synergy, and convergence towards a common goal. I exercise leadership with humility and characterized by stewardship. I lead by example, walk the talk, and celebrate success as owned by all the members of the team. I embody concern for stakeholders, especially the welfare of our members, employees, and all we work for, and those who work for us. I am an integral part of a resilient, nationalistic, and God-fearing organization. I weather the odds and implore peace, harmony, kindness, good work, love of country, and social responsibility.
For the formal opening of this year 2-day webinar, JPSME National Design 3D Modeling in CAD Basics, may we call on the outstanding and committed National Vice Representative, Ms. Christine Calasara.
Good evening sa inyong lahat, and I am very much honored to have you all here. So I would like to welcome you all for the first day of a very much anticipated 2-day JPSME National webinar. In honor of this, we would like to each and ask you to join us for all over the country and beyond for this extraordinary event dedicated to exploring the latest trends, innovations, advancements in concepts, principles, designings, and computer-aided science. We'll be taking an exciting voyage through the realm of mechanical engineering designs for 2 days, where activities mix technology and redefine every fabric of design. The goal of this webinar is to provide a dynamic platform for learning, collaboration, inspiration, and by bringing together the brightest minds, experts, and enthusiasts in the field. Moreover, this webinar is not just about theoretical concepts, but a celebration of practical insights in the real-world applications and the fusion of imagination with the technology and powers. This unique opportunity to exchange ideas, foster connections, and ignite a passion for excellence in mechanical engineering design. So sit back, relax, and enjoy the sessions as Raffle prizes will be given throughout the seminar. Thank you, guys.
Once again, thank you very much, Ms. Christine Calasara, for that wonderful speech. And now, today's talk, it embodies the spirit of understanding and empathy and empowerment and through this talk. And we encourage you to engage actively, to absorb this wisdom shared, and most importantly, to reflect on how these insights can be woven into fabric of daily lives. Without further ado, let us now proceed with our first talk speaker. He is a licensed mechanical engineer and instructor from Visayas State University and manufacturing engineer from Muramoto Audio Visual Philippines Incorporated, 𝒂𝒃𝒃 Lapu-Lapu City, and trainee of Energy Development Corporation, EDC Tongononan 1G Thermal Production Field. Let's give him a warm welcome to our distinguished speaker, Engineer Vic Angelo L. Impas, MSME.
Right. Thank you so much, Mr. MC, for the introduction. So for now, I will be going to present my presentation for today's topic. Okay. I believe my application window is already shared to the platform. May I hear some response from the committee or from the MC? Okay. So based on the platform, it is already presented. So with this, I'm going to start my discussion regarding the mechanical design principles. No, so thank you for inviting me for this wonderful 2D technical webinar hosted by the JPSME National. So instead of going through broad discussions on this kind of topic, so I'll be making it simpler, especially for those aspiring first year BSME students, no, from the entire Philippines. So again, my topic will be the mechanical design principles. The topic outline for this discussion will be the introduction, terminologies, design process or designing process, as well as mechanical system and principles. We also have additional topics which will be added on the safety of design of safety factors, as well as um, to call this one. Okay, so later on it will be added at the last portion of the discussion. So for the introductions, humans has an innate ability to create something that could help lives much easier. From the ancient times to present days, no, countless of inventions and creations was created and used in daily lives. So, for example, we have these small inventions from our mechanical tools and equipments, which we are using as we build or repair devices, no, to make things easier for us to do task as an uh, innate ability for our as an individual, no. For the mechanical system, it is a set of physical components that convert an input motion and force into a desired output motion and force, no. It is the same with an individual riding a bicycle, that the input motion and force was introduced or inputted by the human effort and was processed by the bicycle, creating the forward motion, no. And the same with the transmission in our uh, cars as of today's, no. We have also what we called translational mechanical system. This refers to a physical system where motion occurs along a straight line or a straight path. So for example, this one is the compression strength, tensile, as long as it is in a straight line or straight path. We have also what we call rotational mechanical system. This kind of systems refers to a physical system where motion occurs in rotating about a fixed axis or moves about a fixed axis or a shaft. Okay, for example, this one we have a set of pulleys, gears, and etc. No, so we have also what we call a mechanism. It is defined as a kinematic chain in which one link is attached to the reference frame so that a controlled output motion is generated in response to an input motion. So we have some example on this one. What we have the Geneva mechanism and also the sun and planet gear mechanism. So this kind of mechanisms were specifically designed to produce a unique movement that is required to its needed function, no? So as an aspiring mechanical engineers or an engineer, we are destined to build or to design something, no, in order to solve some problems that we encountered in our daily lives, not just in our work, but also in our households. So in the designing process, what are the things to do to design a mechanical system? Or what would be our first step? Again, get a piece of paper and write down that what you want to do or design. No? And we need to define the terms goal and the objectives, the purpose of our design, of course, the problem that you want to solve, as well as the impact of our design. No? Defining these terms are essential to make the design focus on its output. It becomes the guide for the designer to not lose sight on the output as performing the process. No? May it be a small items or a bigger inventions, it must be have these terms, no? It because it will define what you are going to be designed. Then, after defining those terms, you need to create a simple flowchart of your course of action. No? This flowchart depends on what design you are into, and this will become the guide for you as to where and what current phase of your work will be. Then, after you having the flowchart, it is necessary to gather related data or information. No? Reading literatures and getting data from existing and established designs is very essential and correct way to design something. It gives the designer an insights on the project, and eventually it will be the guide on the designing process. And also, these literatures will also become the comparison of your final product at the end. Next, you need to identify or determine mechanisms that are going to be used, including the necessary components on your designs. Of course, for those starters for the first year, these mechanisms will be discussed to you when you will become in the third year students in the machine elements. No, so this is very essential in the designing process, because this part of the process, no, it is where the design calculations and the principles of the systems will be determined. No, so all the calculations or the necessary load calculations will be put on this portion. Then, after the necessary design calculations, we need to model the system based on the identified components and mechanism through a manual drawing or a CAD drawings. No? This part of the process of creating the desired mechanical system through technical drawings with the use of CAD softwares, of course. It is much easier to use CAD softwares in creating detailed drawings. This includes, no, design calculation through the application of design principles and material selections, no, especially in present softwares, which is very broad enough that there will be simulations, no, and material selections that can be inputted on the softwares. Next, once we are able to design the system, we will now simulate the system using, of course, simulation softwares. No, most common of this one is what we call the SolidWorks. No, these simulations will help us predict or view the expected function of the mechanical system. Through this process also, the design can be improved and optimized based on the simulation results. And after that one, of course, we will now convert the detailed drawing into tangible output with in which it will be fabricated. And once it will be fabricated, we need to test the design and also an evaluation. You know? Because the mechanical system must be tested to check its functionality and also the efficiency. A comparison must be laid down together with the simulation process, which can be used as a guide in evaluating the performance of the system. As defined earlier, no, we have the mechanical system. In the mechanical system, we have three elements that we need to understand. We have the input, the process, and the output. In the input, it is in any type of motion and force that drives the mechanical system. May it be a human effort, an energy from the wind, water, heat, or it may be a chemical reaction or electrical. May it be pneumatic or a hydraulic device. And through this input, in the process part, it is where the mechanism that are used to convert the input into the desired output. No? So in the process, it is where the mechanism or the mechanical mechanisms that converts the input. Then the output is where the change created in the input motion and forced by the mechanism. So for example, no, a simplified diagram of the crank and slider mechanism in an internal combustion engine. For the input, we have the fuel ignites, causing gases to expand, which force the piston down, no, when the fuel ignites. Then, as a result, in the process portion, the crank and the slider mechanism converts the reciprocating motion and force into a rotary motion and, of course, the force. And with that, the output, the crankshaft rotates and deliver the motion and force to the wheels of the car. No? So, one example na that. Of course, to a much simplified mechanical system, we have also the bicycle. No? How I wish I could interact to the audience to spot the mechanism on the bicycle. May I hear some comments from the audience to spot or give the numbers present on the bicycle? Where is the mechanism will be? May I hear some comments or type on the chat? So for example, on the mechanism on the bicycle is in the number 3, which is the brake system of our bicycle. No, that is one of the mechanism on the bicycle. Okay, now number 14. Yes, it is the crank on the pedal. Of course, together with number 13, number 12, which is composes the chain and sprocket. No, basically the pedal, it is where the downward force from the human input, no, and the chain and sprocket combination, no, drives the rear wheel, no, causing the bicycle to move. Yes, the number 3 also. Okay, thank you for the response. No, so in a mechanical system, subsystems can be integrated and assembled to contribute specific output. And in the subsystems, mechanisms are connected and assembled to work as one to produce the expected output of the subsystem. No, like in the example earlier, in the internal combustion engine, no, there are a lot of subsystems on the internal combustion engine. No, example of that is that we have the ignition system, we have the timing system, cooling system, valve system, as well as the fuel injection system. No, of course, the bigger the equipment it is, the more subsystems will be present. No, doing the work to produce specific actions. Of course, the system and subsystems, there are some of the basic uh, calculations and design formulas that we use. No, it was discussed on the course machine elements, wherein it is purely on kinematics as well as on the machine design course. No? On the machine elements, it deals with the motion and forms of parts of machine and the manner of supporting and guiding them independent of their strength. No? The study of movement of bodies without considering the force causing such motion. So in this subject, no, The machine elements only considered the motion, which is on the velocity as well as the acceleration of the mechanism. While on the machine design, the calculations is involved already the forces acting on the different parts of the machine or on the machine elements, and selection of materials based on the strength and other physical factors. So what are the guiding mechanical design principles for us to consider in starting or creating our mechanical design? We have a principle from Occam's razor. No, keep things simple to start and add detail as design develops. No, keep it simple at first since we are still starting. Then a problem should be stated in its most basic and simplest terms, and the simplest theory that fits the fact of the problem is the one should be selected. So the problem must be simplified and must be direct. Then detailed design gets done at the component level. No, it is much easier to start at the smaller component level. Then keep functional requirements of the design in mind. Of course, we need to keep in mind the design requirements that we identified as well as the implied functional requirements. And also, our goal is to minimize the number of components and balance components complexity. No? As much as possible, minimize the number of components to make it much simpler. But of course, if the equipment is again bigger than notebooks, no, for example, may it be several number of components, again depending on the type of machine or design you are into. We have simplicity and complexity. No, create designs that are explicitly simple. No, again, it must be simple. The less thought and less knowledge a device requires for production, testing, and use, the simpler it is. No, because if the design or the output is complex, of course, the production and other processes might be also required complex or much be difficult. No? Of course, it may take lots of thought and knowledge to get to a design requiring little of. Of course, it is designing process. It is not just as snapping your thumb that can be done in a 1 hour on a one day. No, the designing process takes time, of course. Then, what a simple design means is that everyone involved with its production sees nothing that looks complicated from his or her own perspective of convention. Complexity is varied and invisible, no? Such as screw threads have abundant specific scientific and manufacturing complexity. Yet the complexity is invisible to the designer, no? Of course, manufacturing screw threads nowadays, much easier. But of course, there are a lot of scientific calculations in designing screw threads also. No, complex geometry no longer implies a complicated design. A part's geometry may be complicated, yet its production and use may be no more difficult than for one with simpler geometry, of course. No, simplicity can be subtle, of course. Design symmetry into components. If a part is asymmetric, knowledge and thought are needed to orient it for either the assembly or the use. Assembling or using symmetrical parts requires less knowledge and thought than asymmetric parts, of course. Two common techniques for keeping things simple by keeping complexity hidden are, of course, purchasing rather than making components. Of course, if the components are already available in the market, I think it is much easier, no, to use that one. Of course, it depends on our design specification. And second, specifying components by, of course, the standards. No, so these are the two common techniques. We have also laws of nature. No, to develop a physical model of an existing system or of a system concept, we use engineering judgment and make simplifying assumptions. No, for example, you drop a strong cylindrical magnet down a copper pipe with a plenty of clearance between the magnet and the pipe wall. So what happens? How many laws of nature are illustrated? Of course, may it be Newton's second law. We have also Newton's law of gravitational. No, of course there are several laws of nature in that specific action. No, to develop a mathematical model, a model that can predict system dynamic behavior, we apply, of course, the laws of nature to the physical model. No, we have also what we call Saint Binance principle. The principle says that several characteristic dimensions away from an effect, the effect is essentially dissipated. Or if an effect is to dominate a system, it must be applied over 3 to 5 characteristic dimensions of the system. So for example, we have this shaft, no, and the green one is the bearings of the shafts, no. On the illustration, we have the bad condition and the good condition. At the right side of the illustration, that is what the Saint Binance principle um, means that, no, the two bearings are separated over 3 to 5 characteristic dimensions, no, to avoid or to minimize the movement of the shaft, the bending movement of the shaft, of course. No, when mounting bearings to support a shaft, no, the bearing should be spaced 3 to 5 shaft diameters apart if the bearings are to be effectively resist moments applied to the shaft. No, so to avoid no vibrations or moments bending of the shaft, no, the bearings should be separated to that 3 to 5 characteristic dimensions. We have also what we call the golden rectangle. The golden rectangle discovered by Pythagoras is a rectangle whose sides are in proportion such that when a square is cut from the rectangle, the remaining rectangle has the same proportions as the original. No, I think it is everyone is familiar by this figure. No? Of course, if the pattern of subtracting squares continues and a spinal curve is drawn by linking together circular arcs whose center are the corners of the squares, no, then the spiral continues to infinity. No, so when designing a machine, one can either start from the outside and work inwards, or start from the inside with a critical module, then design the outwards. No? A compromise from the beginning can be achieved with either method by initially sketching concepts while keeping the proportions of the golden rectangle in mind, including in Saint Binance principle, should also be considered when laying out proportions and spacing of machine elements. If, for starters, if we don't know the size for our design, we can start the ratio of about 1.6:1, as suggested by the golden rectangle. We have also what we call the independent functions. No, keep the functions of the design independent from one another. No, during the concept development stage of the design process, no, on this camera and in the tripod, no, this is not easy as it sounds. There will be temptation to combine functions and features and thus compromise the design. No, consider the ball and socket tripod in the head of the camera. No, this one, ball and socket tripod for head of camera. No, the movement. No, there is no functional independence of the positioning and locking. No, we can move the camera in all directions. No, and the improvement in separating functions. No, in here, the tightening the nut creates the rotational friction between the nut and the balls. No, so as we tighten this nut, no, of course we lock the position of the camera. It could be, however, no, to seek independence of the functions, no, it was innovated and accepted that everything in the design, including the independence of the functions, is compromised. You need not to take unyielding posture to any role of design. No, so in the current phases, the levers are added on the tripod, no, or and handles are added, used for two functions: positioning and locking of the camera. No, of course, combined adjustment and locking functionality reduces part count and operates intuitively. No, so mas specified ang iyahang movement and mas easy ang iyang pag-operate. We have also the Abyss principle. The amplification of angular motion to create large translational motion is one of the foremost principles in the design of precision and robust machines. No? Always try to place the measurement system as close to the line of action, no? The process, as much as possible. No? For example, when measuring temperature, it is important to place the temperature sensor as close as possible to the process to be measured, of course. The same with measuring using caliper and micrometer. No, we have also what we call self principle. Use an object geometry or other property to prevent a problem. We have stability is of utmost importance in the design of structures, actuators, bearings, and control system. No, in protecting one component, the design engineer must make sure that the effect does not ripple through the system. No, so it must be stable. Always, all systems are either stable, marginal stable, or unstable. No, for example, we have this kind of figure. The first figure is classified as unstable. No, because it may move based on the weight of the object or the blue color. No, while the marginal stable in the blue color circle, no, lying on a horizontal strip or plate, and the third one is the stable one, wherein the blue circle is positioned on the bigger circle at the bottom. No, we have also what we call symmetry. In general, symmetry is a good thing in a system. That's a good starting point in a design. No? Symmetry is a principle that is closely related to stability. Symmetry can sometimes provide, of course, stability. No? In structures, symmetry may exist on overall scale, such as between two sides of machine, but within each sides of the machine, symmetry takes seconds place to describe formation of triangles. No? So as much as possible, if allowable, it's much better that the design of the components is in symmetrical, condition. We have also what we call parallel access theorem. You know, the parallel access theorem is a very good, powerful tool for calculating the area moments of inertia, especially for complex objects. We may add mass away from the neutral axis to increase strength and also stiffness of the materials. We have what we call also the accuracy, repeatability, and resolution. No? Make your machine repeatable first, then tune for accuracy if you have fine enough resolution. No? Repeatable meaning can be reproduced with the same output to the first design, then making it or can be innovated to make a higher resolution. A good machine designer understands and has developed an intuitive feeling for the factor that affect the machine performance. Equally important, the design engineer must also understand the basic physics that characterize a machine components or systems. This knowledge is essential for the development of good designs and proper selection of components. So almost all subjects in the undergrad are very useful in machine designing, of course. So it is very important to study well on the subjects offered, especially if we want to design something. So in minimizing machine cost and maximizing machine quality mandates predictability of accuracy, repeatably, and resolution. This allows the design engineers to optimize the choice of components to specify manufacturing tolerances. Of course, three basic definitions to remember with respect to how well a machine tool can position its axis. We need to remember the accuracy, precision, and resolution. Meaning, the design that we made must be efficient enough to what is the functions or what is for what is the function intended to be. Accuracy is a measure of how well a system can achieve, or measure a state that is traceable to a national or international standards. Of course, when designing something, we need to see some international standards, especially in the American Society of Mechanical Engineers. A lot of standard set for designing components. We need to look at that one. Repeatability tells how well a system can achieve or measure the same state each time. Repeatability is the error between the number of succeeded attempts to move the machine to the same position. So basically, repeatability is during the test process. Several processes or testing process. Then resolution is the ability of a system to tell the fine details of the story or what is the minimum increment that can be detected or moved. Then we need to classify each of the motions on the concept required in terms on the accuracy, repeatability, and resolution. Of course, we need also to map or mapping, which is the ability to measure or predict the repeatability of accuracy of the machine, and then use this knowledge of the error to compensate for it. We have also what we call sensitive directions and reference features. We need to establish reference datums from which you measure critical parameters. That is why we need to look at established designs, related literatures, no, that can be referenced in our design projects. Then always identify the direction in which accuracy and repeatability are most important. We have also triangulate for stiffness, no? Triangulate parts and structures to make them stiffer, no? For example, we have this wooden gate. No? As the gate swings, no, it may sag, no, depends on the weight of our gate, no. Of course, we can put a tensile cable connects from the lower outer corner to the upper inner corner and transmits the load to the gate post, no. Or we can put a brace like this, no, to make it stiffer, no, that can, so that it can withstand the weight of the material that being used. No? We have also what we call ribs, no, are common in molded and cast parts. They efficiently stiffen the structure by using thin braces, which are required by many manufacturing processes. No, because if this part alone, no, it may not be strong enough to hold the screw. That is why a triangulate part are added to make it more stiff or can withstand the given load. To triangulate, we need to first identify the plane in which the load and the unreversible stress or deflection lie. No? Then add integrally attach the ribs, weaves, flanges, or truss elements in that plane. No? Stiffer does not always mean stronger or more robust. Stiffening transfers loads to a different place, no, a place that might be weaker or more susceptible to fracture, fatigue, corrosion, or whatever else leads to failure. No? So, for example, with these cover cases, no, on the left side, the holes of the screws together with the ribs, wala pa siya no triangulate parts are added, no? Unlike on the right side, triangulate parts are added on the hole portions as well as on the ribs, no? No, the rib holes maintain strength while providing uniform wall thickness, no? Then of course, less cycle time plus material, fewer defective parts during manufacturing also, no? Basically using ribs on the casing of our products, no, making the casing more durable than the plain ones. We need also to have the load paths, no, plan the load paths in parts, structures, and assemblies, no, draw a line through the path that forces follow and seek to minimize its length, no. If the path and the shape changes significantly as the machine moves, then the machine will have limited accuracy and may have limited repeatability, no. So again, we need to identify the load paths, no. Whenever you design a part or assembly, you should clearly define the paths of the applied and the internal loads, no? Then the first step in planning the load path is, of course, visualizing it, no, to where the path or the force leads to. For example, we have this the lever of our bicycle, no. The bicycle handbrake is squeezed rather than pulled or pushed, no. The load path is locally closed, no, pulling rather than squeezing the brake lever, no. For example, if our handbrakes on our bicycle is through pulling or pushing, no, it it would give us or the rider's arm, no, stress from performing the braking system, no. That is why a specialized braking system no, was designed to make it simple, no. Locally based paths are specifically prepared, no. User-centered design benefits from locally closed load paths, no. Always considered how user-generated forces are opposed, no. So again, we need to consider the input energy before we design something also. Of course, we need to avoid bending stresses, no? And we prefer tension and compression stresses, because on the bending stresses, no, the distribution of the stresses that may vary from 0 to some maximum, no. Then the material is unstressed and distribute nothing to rigidity of the strength, no. So while on the tension or on the compression, no, all part of the material, no, um, reacts to the force, no, making it more durable, no, compared to having the bending stress, no. Almost all particles of the, for example, the shaft, no, resist on the force, while on the bending, only small portion of the material, no. Also, we need to manage the friction, no, avoid sliding friction, and use rolling element bearings, no. A good minimum rule of thumb for length to width and for length to load arm is 1.5 to 1, no, and your design must guarantee contact only at the ends and in the middle of the moving component, no. Managing sliding friction is difficult, of course. Stick slip behavior owing to differences between static and dynamic friction, wide variation in friction coefficients, uncontrolled lubrication status, variable surface finishes, surface damage, and wear. So that that is the sliding friction, no. While on the rotary motion is much better selection over linear motion in mechanical designs, no. Linear motion works with proper guiding and with good linear bearings. Also, you need space and lots of it for linear guidance, no, for sliding friction, no, more space than the rotary motion. Of course, it's because the sliding friction has a greater surface area compared to the rotary friction, no. And also in the design principles, we need to use the FBD diagram, no, free body diagrams and superposition, no, usually found on the discussions on the static and dynamics, no, subject. To analyze a complex object, separate it into parts and label the forces and moments on each part that are imposed by the other parts, no. Of course, we have also what we call centers of action, no? If forces are applied through the centers of mass, stiffness, and friction, there will be no moments, and hence, with that, there will be minimal errors, no? If forces are applied through the center of mass, mm, so when minimizing moments on a system, of course, the angular motion also minimizes, no? And since the moment are minimized, no, the robustness of the design can be enhanced also. And we have also what we call the exact constraint design. No? The number of points at which body is held or supported should be equal to the number of degrees of freedom that are to be constrained. No? Use exact constraint when designing structures and mechanism. So, of course, never over constrain a design. So we need to use exact constraint, no more, no less. For example, this kind of shop installment, no, there are 3 bearings on one shop, no, it is not luck, no, in trying to fit the shaft through the 3 bearings. And this kind of design is over constrained design, no, because we can use 2 bearings in a one shaft only, no, to control the movement through bending of the shafts, no. A three-dimensional object, of course, has a 6 degrees of freedom, no, 3 translations and 3 rotations, as shown in the figure, no. Selectively constrain these degrees of freedom to obtain the desired motion or structure, no. So how we can constrain? Of course, you need to put something and to oppose the predicted movement of the specific object, no. A constraint is a point of contact maintained by nesting force wherein the nesting force vector goes through the contact point normal to the surface. On the figure, no, the plate cannot move to the x-axis because of the constraint part. This one, no, it cannot move, but the other axis can move. We have also what we call two post constraint design, no, for this one. Of course, this kind of plate, the plate cannot move to x-axis, go into this direction as well as on the y-axis to this direction, no. We can also put in within this way. And of course, the rotation on the z-axis was also constrained when two poles are put on this kind of position. So this is a real world example in exact constraint design, no. At first, no, there are many screws present on the mounting of the motor, no. This is a linear drives for scanning, often consists of motor attached to the lead screw, no. When in turn drives the scanning carriage, the first design, this is the left, no, showed a cyclic error in the linear motion, more accurate machining, better part alignment, and more expensive lead screw, no. So again, daghan siya mini installed lead screw, no, to mount the motor, no. And a constant analysis was performed on that part, no, and it was discovered that it is overly constrained, no. That's why it was been redesigned, no, to minimize the material used in the on the production of that part, no, causing less production cost, of course. And of course, if the production cost is less, the price on the market would also be less, depending on the design. Design constraints are the factors that restrict or impact how a mechanical system or product can be created. No, they cover technical, functional, cost-related, environmental, ethical, and aesthetical considerations. No, design constraints are firm limits, no, sa atong design. No, it must be uh, identified earlier, no, that must be met for the design to be acceptable. So of course, no, examples of this are the product specification, such as time frame, no. These are some of the example of the design constraint. Of course, time frame, how long we are going to manufacture our product or to produce our product. Of course, the budget or the finances that we have, the power levels, surface temperatures, and etc. No, this can be specified by the customer or by the nature of the problem. limitation of the fabrication process, or of course the technology. No? So how are we going to identify design constraints? No? Of course, firmly by asking questions. No? A highly effective method for pinpointing design constraints involve asking questions. These inquiries aid in grasping the requirement and anticipation of various stakeholders. No? Ang atong client, depende sa iyang gusto, users, manufacturers, and regulatory society. No? Questions also assist in analyzing the context and breadth of our design issue, including the purpose, the function, performance, reliability, safety, or sustainability. No, as a future mechanical engineers, we are bound to have a project base, no, and we have clients that want to have or to build something, no, and as we design, we need to ask the clients what are the limitations or the requirements that he or she wants to his or her product, no, and that would be our design constraints. And also to conduct research, no, discovering design constraints is greatly facilitated by conducting research because it offers valuable insights and data concerning the design problem, may also have the current solution and potential opportunities. No, it's instrumental in benchmarking and comparing your design against industry-based practices and standards. No, various methods like literature review, market analysis, user analysis, and experimentation can be employed to achieve this one. No? Another one, we may use tools and techniques. For example, brainstorming, morphological analysis, matrix methods, diagrams, and prototyping. No, brainstorming involves generating a large number of ideas or solutions for the design problem without judging or filtering them. No, so these are some of the basic thing to do to identify design constraints. No, and now we'll come to the material selections. In the given figure, no, it illustrates the kingdom of the material, and it was divided into families, classes, subclasses, and members. No, for example, on the kingdom of in the kingdom of materials, we have the ceramics, glasses, metals, and etc. For example, we have in the family of metals, we have the class of the aluminum alloys, no, and the subclass is the 6000 series, no, and also the members. And of course, each member of the aluminum series has specific material properties. No, these material properties are already standards, no, given in the industry. So based on our design calculations and machine design subjects, no, as we perform the design calculations, no, we look at the attributes of the materials, no, in choosing the right material into our design. No? And in the selection strategy for the material selection, we have the 4 steps. We have the translation, screening, ranking, supporting info. No? In the selection involves seeking the best match between the property profiles of the materials into the kingdom and that required by the design. Of course, no? As we perform the design calculations, no, of our project, no, we need to select what is the best material to be used, and to do that we need to employ these 4 steps. No, this is like uh, screening or selecting job interviews. No, in the translation, examining the design requirements to identify the constraints that they impose on the material choice. No, so we need to examine the design requirements, and after that if we already obtained the design requirements, we can now narrow down the materials that we are be using through screening based on the design constraints. Of course, those materials that do not meet the design constraints or the design specification will be removed on our list. Then after that, it will be the ranking part. No, we will be further narrowing the list of the materials. No, by their ability to maximize the performance. No, based on the material or the standard material properties. No, and after that, the supporting info phase. No, this is the final stage wherein the references and interviews are sought for the top ranked candidates, of our material on the list of materials that we obtain, based on the character and material properties on the specific material. Of course, it depends on the factors of budget of the project also. So to simplify those on the material selection, from all the materials given in the industry, we have to translate design requirements, from constraints, objectives, and variables, as we discussed earlier, Then after that one, again, we need to screen using that design constraints. Of course, eliminate those materials, that do not meet the design constraints. And then we need to rank up those material based on the objective of our project. Then of course, we need to have supporting informations or other supporting design constraints, before we can finally choose the best material for our project or mechanism. Of course, we also have the factor of safety. In mechanical engineering, mathematically, factor of safety is the ratio of material strength and allowable stress. For example, if the required specification of shaft is to withstand a 100 kilogram load, but if our shaft design is for 200 kilogram load, therefore ang atong shaft safety factor will be had a value of 2. The factor of safety is essentially used to assure the structural designing does not occur any unexpected failure or presence of deformation or defect. The smaller the factor of safety, the higher the chances was there for the design to be failure, resulting in an uneconomical and non-functional design. So much much preferred kung dako or bigger ang factor of safety sa ato ang material. Safety factor is usually expressed as a ratio percentage. For example, a safety factor of 2 means that the structure can resist twice as much load as it is designed for, or it has a 100% margin of safety. A typical safety factor range is between 1.2 to 4, depending on the type of structure and load. Basically, using materials and higher load capacity compared to what is required by the given design. Majority of mechanical designs, we come now on the optimization. Majority of mechanical design includes an optimization or task which engineers always considered certain objectives, such as weight, wear, strength, deflection, corrosion, and volume, depending on the requirements. The purpose of optimization is to achieve the best design relative to a set of prioritized criteria or constraints. This includes maximizing factors such as productivity, strength, reliability, longevity, efficiency, and utilization. No? What are the methods on optimization process? We have the analytical methods, of course, the FEE, the finite element analysis, the computational fluid dynamics or CFD. We have also design of experiments or DOE. In analytical method, it is a calculus-based optimization, no? Uh, Manual calculation based on the calculus, no? Then we have also softwares, no? For the FEE and the CFD, no? Which is widely used in conjunction with optimization techniques, no? The finite element analysis allows engineers to simulate the behavior of structures under different load conditions, enabling them to optimize designs for strength, stiffness, and durability. While on the CFD, it enables the optimization of fluid flow patterns and thermal characteristics in systems like heat exchangers and aerodynamic surfaces. No, by combining FEE and CFD with optimization algorithms, engineers can optimize designs while considering multiple constraints and performance criteria. No, we have also the design of experiments. No, it helps engineers systematically explore the design space by selecting specific combinations of input variables to evaluate the system's response. No, response surface methodology uses statistical techniques to build mathematical models that approximate the system response to the surface. No? These models can be used to identify, of course, the optimal design of the parameters. Okay, thank you for listening. That would be all for my topic. No, it's a bit wordy for the discussion since it consists of the theories. So I know not all those discussed topics under what I've discussed, but at least portion of those ones will be your guide as you want to design something. Okay, thank you.
Thank you very much, Engineer 𝒍𝒆𝒕𝒔, for accommodating us with such wonderful talk. So we really learn a lot from that, lalo na on the field of mechanical engineering, sir. Lalo na dun sa mga fourth year students and coming fourth year na who will work their thesis talaga, presentation.
Yes.
Malaking tulong tong topic na to for us. So, ayun,
Actually, I incorporated the first slides, no, to like a thesis or project base, no, to that have a problems, statement problem, objectives, no, to guide the projects based on the what is the required output that the student wants.
thank you very much, sir. Thank you for that wonderful talk. And now, let's move on the open forum. For those who have questions regarding Engineer Vic Angelo 𝒂𝒃 presentation, should you have any question regarding the topic of the first talk, you may type it on your question on the chat box. And please follow the format, full name, school, and then question. So you may type your question, guys. So Sir Engineer Vic Angelo will be the one who will entertain your question. So guys, so while you are composing your own questions regarding the first topic, so don't forget that after this we will have our raffle, and you will have the chance to win a premium subscription in LinkedIn. LinkedIn. So guys, so just wait for that. So just comment your question in the chat box, and hintayin lang namin ang inyong mga tanong, guys.
Maybe no, they cannot compose questions in this time, no. But maybe tomorrow or some other time they can send me an email, no. I send my email in the private chat to the host of this event so that they can share that they can share the email address, no, so that they can ask question later on, no, if they have some questions. And of course, if I have time, I can answer those questions of them.
Okay, that is noted, sir. So everyone, if you have any questions regarding with the topic or anything that is about you can reach out Sir Engineer 𝒍𝒆𝒕'𔔺's email. So sir, ayan, meron na pong first question, sir. So his name is John Michael Calales from Batangas State U. So ang kanyang question, sir, where can we attend trainings regarding mechanical design with certifications?
No, so I think the most common platform that we can search for trainings, no, is on the internet, basically. Nowadays, there are a lot of mechanical design trainings on the internet, although it has registration fees or payments, no. But yes, of course, there is certifications. I don't know on the PSME National if of course they have a training on machine designs, no, with certification. May siguro the officers on the JPSME National can also answer to that questions, because no, you are near to the PSME National one. So I think, pero yes, on the internet there are several or many groups offering trainings, but mostly in softwares, no, like AutoCAD, SolidWorks. There are many platforms offering that kind of trainings. Just search up on the internet.
Sir, may next question pa po.
I would like to add something muna from the previous question regarding mechanical design trainings with certifications. So, guys, when you registered actually to this webinar, we did send another G forms sa email ninyo. Please check that. That did include a free registration for trainings with certifications from Autodesk Philippines. So please, yun guys, use that opportunity because that doesn't just happen every day. So yun, I do encourage you to also join those trainings na pinamigay namin. Please check your emails. And if not, kung you were not able to receive that email, please message us sa Facebook account namin sa JPSME National, and we will send you a copy. Yeah, sir. So,
okay, so thank you, Miss. There are other question, no, from Christine 0325 go
Yeah.
CPU.
Yes po, sir. As an aspiring design engineer, in what field would you recommend for us to start?
No, so I think we all know that there are various fields of mechanical engineers, no? We may it be in renewable energy. We have also in HVAC, no, depending on what we are into. But as for me, no, as a design engineer, no, I'm into materials, no, materials engineering, as well as on the wave energy in production of potable waters, no. But of course, as an engineer, Manggod, we need to broaden our mind, no, or our field, not just for the specific field, but for us a student, no. It is best to start, no, in the on what you want to do na lang yun siguro. For example, in you want to do in your thesis, no, I can advise that it it is much better to start in the production of potable water, because nowadays it is very much problematic, no. Maybe in coming years, no, potable waters might be difficult to obtain, no, as well as I think on renewable energy, no. How can we harness much efficient the renewable energies? I think that kuan siguro field nga ako masuggest.
So thank you guys. So let's move on to the next question, sir. From Rogen, from Green Valley College, what is the cost to the machine design if the friction high?
I think ano so ato ning we will redefine or rephrase the question siguro. I think what is the effect siguro, no, on the design if the friction is too high, no. Of course, not all design machines, no, there are also machines that really needed frictions, no. But of course, if the friction is too high on the specific mechanism, no, there is much more wear and tear on your materials, no. For example, you have two materials, moving together, no, and the surface area or the contact area is large enough, no. Of course, the friction is high, no, and with that movement, as the move or operate, no, there will be wear and tear of your materials, no, and of that, if there is a wear and tear, of course, no, materials will may break or failure, no. That is why mostly frictions should be less in the designing process, no. So for example, another one, in if you are in riding bicycles, no, it is in our wheels, no, sa ato ang bicycles or our motorcycles, no, much better that on our tires, no, mas maayo siya dako ang bigger friction, no, because if less pud ang slippage niya, meaning you can move faster, no. So depending on your applications, of course, but then again, mostly frictions must be less good in designing process. Okay, thank you.
So
𝒍𝒆𝒕𝒔.
so let's for the next question, sir. Marantia Gandia from AVSU Main. As a graduating student po, what can you suggest us to focus on regarding sa designing of our thesis and project studies po?
So designing of our thesis and project studies po. Okay, so this is from my home alumni, no, because I'm also from Eastern Visayas University main campus, no. So the question is suggest, no, focus on regarding sa designing of our thesis, no. I think she focuses on the designing of the thesis, no. All parts basically on our manuscript for your undergrad thesis is very important, but I assure you, as a starter, no, you should be focusing on finding problems, on the society, For example, you need to find problems in machines or in the environment, like that. Then once you find the specific problem, try to find related literatures, because the related literatures is very important in your undergrad thesis, Actually, in my undergraduate thesis, it was not emphasized during our time, but when I entered master's degree, the importance of the related literature is very big. It has a big impact as we go along our thesis. So I think identifying the problem, getting the right related literature is very important to focus on your studies or your project studies. That would be my answer, Miss Gandia.
Thank you so much. So next is from Joshua John Arnal. In your experience, sir, what type of mechanism has less cost?
No, again, that kind of question is a blurry one for me, because again, it depends on the function or the application of the mechanism that you will be going to use, of course, So again, if we need to identify what kind of mechanism, of course, and what is the specific type of application that we're going to use. Then with that, if we already identify that one, we can search up, we can canvas to the stores. But to that kind of questions, I cannot answer kung what kind of mechanism ang less siya of cost. Okay? Because again, it depends on the design and also the materials that has been used on that kind of mechanism. Of course, as we all know, products and services, differs on cost, even though they are the same because of the materials that they are been using. Okay.
So thank you, sir. Sir, I have my own question, sir,
Yes. Yes.
regarding. So, sir, as of now, sir, lalo na here in the Philippines, we are actually emphasizing sustainability. So, I just want to know, sir, how do mechanical engineers contribute to the green engineering practices, lalo na
No.
in terms of environmentally friendly designs?
Okay. So that kind of question is very good. No. There are a lot of fields, that embodies or facing environmental problems. I think one of the best way to address that one is to build something or do something in our waste, no because to have greener environment, we need to eliminate waste, of course, so we need to find uh, products or processes, because designing does not only limited to mechanism, products. No, designing or an aspiring mechanical engineers or mechanical engineers, we are bound, to design processes, procedures, products also, so again, the most way to have greenery environment is to eliminate waste, not just for implementing solid waste management, but converting waste into something new. There are a lot of industrial plants that has many waste, in which you can look at into. For example, may I give you an idea? For example, coffee shops. Coffee shops has many waste on coffee granules. Maybe you can try to do something on that one. Maybe in the field of materials engineering, may it be used in building construction materials, like that. For example, like my thesis in master's 𝒂𝒃 is waste from um, aggregate plants, no? Their waste, no? That's called silt. That one, I converted that one into a thermal resistant hollow blocks, no, like that. So that could be a way to contribute greenery environment.
Thank you so much, sir. Ay, sir, ayun lang, medyo na-curious lang, sir.
Yes.
Sir, parang on your field ba, sir, nagkaroon na kayo ng any design or any project na about sa sustainability?
No. Regarding sustainability, no, as of now, I'm not yet involved in that matter, but I'm now starting on flowing that kind of path, manggod, no. Right now, we have also interacted communities, no, in building their or in solving their problems regarding mechanical designs, no, to improve their plants, no, like that. So I'm already into it, no, but as of now, wala pa gyud. I'm still starting also, no, like that. Oh.
How about those, sir, agromechanical, sir?
Agromechanical, yes, no, yes, agromechanical is also a good area to look into it, no, especially in creating something to minimize human effort in agronomy, no. Pero in my side, again, I'm not yet into it because I'm into materials engineering as well as renewable energy. I'm into that.
So, thank you so much, sir. Also, if may mga ayun, may humabol na question, sir. From Adrian Bautista. Hello, Engineer 𝒂𝒃. I am Adrian from Colegio de Muntinlupa. Based on your experience, what application or a software can be used to design projects or machine for beginners? Thank you po.
Okay, so for that one, I think the most basic one is the AutoCAD software. No, I think in most schools, I don't know in other schools, but most schools here in Leyte, no, uses AutoCADs for the second year students, no, to have their drawings, no, to design something because it is the most basic as of now. The most basic as well as learning AutoCAD, no, it can connect to other drawing softwares, no, because the interface and the commands on AutoCADs are also used or present in other softwares. So to that questions, I would say AutoCAD will be the best software for you. No, there is a student version for Autodeskman, so the installation would be no problem.
Thank you. Yeah. Sir, what are your takes, sir, regarding the SolidWorks, sir?
Yes, SolidWorks for simulation, I think that is also best, no? For 3D modeling as well as motion simulation. SolidWorks. I also know SolidWorks, no? But for the here in Leyte Manggod, we don't have yet SolidWorks in our laboratory, no? Pero for 3D modeling simulations, it is based for SolidWorks. I can say that one.
Okay, thank you so much, everyone. Thank you so much, sir. So, if you want to contact and message us, Engineer Vic Angelo 𝒂𝒃, you may contact him at vicangelo.𝒂𝒃@vsu.edu.ph. if you have any follow-up questions or any curiosity about mechanical engineering design. Ayun. Ayan guys. Yan. So, yan ang ika-contact nyo guys. So, that was truly insightful discussion, sir. So, once again, we would like to thank you, our speaker, Engineer 𝒍𝒆𝒕'𝒔, MSME, for taking the time of your busy schedule to speak of this event. With this, we would like to present to you the Certificate of Appreciation. Read the citation. Certificate of Participation is hereby given to Engineer 𝒍𝒆𝒕'𝒔 in recognition of your active participation and enthusiastic engagement as valued attendee at the JPSME National 2-day technical webinar. Your commitment to knowledge advancement, thoughtful contributions, and eagerness to learn have enhanced the conversations and greatly aided in the event's success. Given with the gratitude on 26th of November 2023, with the signatories Christine P. Calasara, Vice President, Representative of Visayas Cluster, and Event Chairwoman of JPSME National. Yours truly, Christian Lawrence T. Philomeno, NCR Deputy and Event Co-Chairman from JPSME National, and the National Representative President of the JPSME National, Jan Abel Ardelis. So, thank you so much, Engineer.
Thank you so much also for having me as your guest speaker for this study webinar. Okay, thank you.
Thank you for giving us such wealth and knowledge about mechanical engineering design and principles. Thank you so much,
Thank
sir.
you.
So guys, kamusta naman kayo dyan? So I hope na meron kayong natutunan regarding with mechanical engineering principles, lalo na sa mga first year students natin and those who are attending this event. So I hope na may madagdag sa inyong mga learnings sa buhay, lalo na diba, we know how hard this mechanical engineering. So now let's move on to the second resource speaker to give us more insight about mechanical engineering design drawing standards. So she is a part-time faculty mechanical engineering department from CIT University, a project-based engineer from T&J Engineering, a project-based design engineer from Line Architect Dubai Cond Renovation, a project management team engineer GMHDC Lapu-Lapu Cebu International College, and hardware mechanical engineer NCR Development Corporated. To give us more insight about mechanical engineering design and drawing standards, here with us Engineer 𝒍𝒆𝒕'𝒔. Let's give her a round of applause. Hi, ma'am. You're not audible po. Hello po, ma'am. Ulit po.
Can
One
you
sec.
hear me or not?
Yes. Okay na po. Everything is good.
Am I loud and
Everything's...
clear on your end? All right.
Yes.
Okay.
Loud and clear, ma'am.
Okay, well, once again, good evening to everyone. Just a brief context about this topic now. Before that, rather, I was not supposed to be your speaker for tonight. So a few days ago, the team contacted me to rescue because you're the original speaker backed out. So please understand if this is a very quick, or let us say this is just no preparation at all. This is what I teach to my students based on um, industry requirement, and I have taught this subject, or I have taught this topic in for one semester. And I'll try to stream it down within an hour of crash course on standard drawings or basic principles of an engineering drawing. So for those who were under me or naging teacher niyo ako before, I hope you got learnings from that. And tonight, for the benefit of the others or the students, um, in the Philippines, di ba? All around the national ba tayo? Luzon, Visayas, and Mindanao. Is that
Yes, ma'am.
correct, Christian? Yeah.
Yes,
So
we're
for the benefit
international.
of all the students, no, I teach this because most of the schools, or most of the schools do not or are not able to like impart this knowledge to their students. That is basing on my industry experience. So with this, I've learned my lesson during the time that I was working. I didn't know this when I entered, when I work in the industry, but I learned in the industry, and I'm trying to share it to the students so that you'll be able to know the basics beforehand. So before kayo sumalang sa industry, you already know this. Um, Whereas kami noon, hindi kami tinuruan, hindi din kami nakapag-attend ng mga trainings like this. So please do pay attention, and in as much as possible retain much of this topic, kasi this is a practical application, and magagamit nyo talaga siya when you are already working in different industries, or in different fields sa mechanical engineering. So without further ado, allow me to present my screen. And I'm kind of disappointed with I don't have any interaction with the with the students or the audience. One moment. Let me set it up for a while. And all right, so I'm now sharing. Can you all see my screen? So I hope those who are attending the webinar right now can interact with me. No. Anyways, I'm here to talk about first. There's two parts of this presentation. I have the first part is the basic drawing principles, and the next part is the standard practices. So that's that. When we say basic drawing principles, I know you already know this one, but let's just jump into it and relearn about this. So probably some of you already know this, some of you does not, but let's jump in, relearn it again now. So speaking of basic drawing principles, we have what we call the fundamental parts of a drawing. By the way, my topic supposedly was right after you learn 3D modeling, because what I saw, there is another speaker that will be talking about 3D modeling, and I said, yeah, I would like to deliver this topic of mine after the 3D modeling, because this comes after the 3D modeling that you'll be learning. Pero nauna kasi to, so let's learn na lang dito first, and then you learn 3D modeling right after. I think that would be tomorrow. Okay, so in 3D modeling, of course, you involve 3D, but this one, you involve 2D drawings. And what are these 2D drawings? what should be in a 2D drawing, what are the fundamental parts, what are the do's and don'ts in a 2D drawing. So there are 7 fundamental parts of a 2D drawing, more specifically on design drawings now, because mechanical engineers or mechanical engineering mainly involves design, modeling of parts. Say, for example, what can I say? Okay. Say, for example, your calculator, right? Your calculator is made up of how many parts? Probably hundreds of parts. I'm not sure if it will be made up of 1,000 parts, but surely 100 parts, more or less 100 parts, right? Each of these parts are carefully designed by an engineer, okay? You as an engineer have something to do with the design of your calculator, design of your mouse. You as an engineer has something to do with this. I have worked in an industry where we design ATM. So that's what one of my experience before. I worked for NCR Development Corporation. I was part of a team that designs ATM. So if you imagine an ATM, automated teller machine. I think you've seen already ATMs. See an ATM right there. But you know that ATMs is composed of thousands of parts. Inside it, there are modules, different parts, sections, safe, the PC, so on and so forth. And those parts are carefully designed by none other than mechanical engineers. Well, of course, let's not eliminate the participation of other engineers in the designing phase as well, but the major areas there, most of the parts there are designed by mechanical engineers, which later on, if you will work in a design company, you will surely be acquainted of. So going back to my topic, you have to identify first the fundamental parts of drawing. So I've said there are 7. First one being the drawing block. So as you see there, actually, this is what I made and what I am using for my students' consumption during their design plate making. So this entirely with the grids you see all over here. The letters and the numbers signifies the zoning. So we say zoning. So if we identify zone A, that's row A. Column 2, that's A2, zone A2. So you are creating a grid, an invisible grid, wherein you can locate certain areas in your drawing where you want to communicate something to other engineers. So we'll go later on. I'll show you later on how that's used, but that is mainly the reason or the usage of a drawing block. So if you see a drawing block later on, whether it's a standard drawing block by ISO or a standard drawing block by ANSI, know that there is a purpose why there is a letter or why there is a number, and that is the zoning. Okay? That covers up, let us say, in layman's term, that's the border of your drawing. In this case, this is a customized drawing block just for educational purposes. But in our industry, in Philippine setting, we have the OBO standard, OBO, that's Office of the Building Official. Is that correct? Building officer, or building official? I forgot. Anyways, that's OBO. OBO is a governing body in our government, or it's a body in our government that approves drawing plans for buildings, for structures, for occupancy, so that we can use the building. So before we occupy a certain space, whether it's a building, a mall, condo unit, something like that, it needs to go through OBO. They regulate everything. They check everything if it is up to standard, if it accomplishes the requirement of the occupancy of the building or the structure. So in OBO, they have a specific, for a moment, I have my cat right here and it's disturbing me. So for oboe, they have this certain specific call that drawing block where you need to follow that one. So you might be able to come across that one. Right now, I was not able to place it in my. There you go. I have my cat right here. One moment. I was not able to place it in my PowerPoint, but I hope I can share it later on as we go on with the presentation. All right. So that's the first part, the drawing block. Another part of the drawing is, of course, the title block. So the title block contains all the information that is needed for your drawing, such as who draw it, what's the description of your drawing, what's the scale of your drawing, what's the size of the paper that is that you use for this drawing, the details, the ownership, everything is in the title block. And again, in Philippine setting, there is what we call, again, the oboe standard drawing block, wherein you have to satisfy the required oboe standard drawing. So again, this is an educational version only of the title block. Know that it is very important you do not leave anything blank. So if there is a portion that you need, there is a blank, it must be placed with name placers or something that is, say for example, there is a needed information there that is not applicable. Just place in like a dash or something, just as long as it is not empty. Okay. Well, you could place an empty if there's not really no data. That's acceptable regardless. But in as much as possible, you leave nothing blank in a title block. Okay. Next part are the drawing views. So in mechanical drawings, not construction drawings, but in mechanical design drawings, we have what we call this drawing views, such as, for example, this one. We are projecting different views of a certain model. Okay, so that's the drawing views. In construction, we usually have it in top view, right? Top view, wherein you can see the entire floor plan, and there we can place in, say, for example, our fire pro or our sprinkler layout. Say, for example, like that one. But before we've laid out our sprinkler layout or our orientation of this our sprinkler design, we already place in a drawing view that is the top view of the floor plan. Okay, so there are actually two directions for a mechanical engineers to learn in the industry. It's either you're going to mechanical design or you're going to in construction. So construction drawings and so probably maintenance drawings, or they're somehow the same. No, it's power plant, same. But in design field, such as product design, so you will mainly involve what you're seeing now in your screen. Okay, we got for a moment. All right, now to proceed, another part is, or this is a very important part rather, which is the dimension. Note that the dimension says everything of your part. When you are creating or you're designing this drawing or this part rather, in order for you to convey your message to your manufacturer, you need to dimension it properly. And later on, as we progress in this topic, I'm going to discuss to you how to properly dimension your design. So it is in proper dimensioning that you are able to show. Give me one moment. Okay, I'm very sorry for the interruption. I just got rid of the cat. I killed it so that dili to siya mag-disturb, so that it will not disturb me anymore. Then, anyways, joking aside, I just let it out first so it will not disturb me anymore. Okay, going back to the dimensions now. it is important for you to properly dimension. Why? Dimensions in a design entails cost. What do you mean by cost? Over-dimensioning your part right here, or drawing here, over-dimensioning means you are asking the manufacturer to check all those dimensions. Say, for example, when I'm going to manufacture this part, and I say, oh, you check manufacturer, you check this, and you check this. Per dimension, the manufacturer checks your part if it's according to the dimension that you have specified. So when the manufacturer checks more dimension, it will entail more man hours. So if there are more man hours, it will cost more, because they're going to pay that person or that engineer or quality checker of your part. So the cost adds up. So be careful when dimensioning, because the more dimensions you have, the bigger, or there might be an additional cost to your part. Later on, I will expound on that topic about why we don't need, or why we need to be wary of our dimensions, so as not to under-dimension and not to over-dimension. Okay? Another part of a drawing, fundamental part of a drawing, are notes and annotations. So it's very important for us to convey notes and annotations. Why? Because notes tells us a specific requirement or a specific description that designer wants to convey to a manufacturer. Say, for example, I am the designer of a part, right? For example, this one here. By the way, the drawing that you see in your screen is made by my student. It's an assembly of an hourglass. So I'm somehow proud that they are able to design something like this. Okay, it's a design of their own, by the way. So going back to the drawing, say for example, what's stated in the drawing notes number 2, the material should be gold, iron, and platinum. So it, depending on the specified material that you have placed in your 3D part itself, you can place in the dimension a general reminder to the manufacturer to achieve or to accomplish your requirement, including the finish, the screw type, so on and so forth, anything that you can add in your part. You can add in the finish, the colors. By the way, in designs, there is no such thing as red, blue, green colors. Colors are coded in design. So you may find, if you have time, try to search for the colors in Google. They have a specific coding, standard coding as to what color you'll be applying to your part, for example. So you can include that in the notes. Say for example, black 00 color made up of a plastic material. Let us say this is 3D printed, something like that. You can add it in the notes. Okay. Another important part is for this time around, this is already involving assembly. So in case that you are already putting up together 2 or more parts, combining it together into an assembly, such as this one right here. This is not composed of only one part, but couple of parts put in together. So when you're already creating the drawing of that assembly, you will have to place in as well the bill of materials. Okay? And the bill of materials will compose of your part numbers, designated parts, and it's sorry, I tend to speak Bisaya. I always forget that there are many multi-languages here. Okay, so in item, it includes the item number or the part number, the part description. You can even include the material. You can even include the weight, the quantity, But the basic requirement of a bill of materials is just the part number, the part name, and the quantity. That's the least three categories that you just minimum requirements of a bill of materials. The rest are just optional, such as the description. Such as the description, the material, the weight. Those are just optional. What's important is that you add in the three: the part number, the part name, and the quantity. Okay. And lastly, for the fundamental parts is the revision block. The revision block mainly composes or are only placed when there is a change of your design. Say, for example, what you see here in your screen. We go back now to the one I've mentioned earlier about zoning, diba? In our drawing block. See? Zoning. Okay? Now, this time, we identified zone B1. That's this one here. B, and this is 1. So, some sort of this grid like right here. I'm going to show this one. Here and here. So, this is the one it's referring to. So, it's actually telling you to look into this Rev B. So what changed from the first revision, on the first version of your drawing? What changed is that the surface finish. So it's the revision block is very helpful when you're working on a part that is designed by many designers, or let us say after you design it, there might be someone who will change something in your design. It actually is involved in a designing team. Say, for example, I'll be the designer. Like after a week or two, I'm designing other things, and this part here is transferred to another designer, and that designer is going to change something in my part. So this one here is like a history of what you have did in with your part. It's also very important when you're working with a team, because without this, you will not know of the history of the changes of the parts. So by the time you encounter things or this part right here, make sure to pay attention to the revision block and read its history now, so that you'll be able to know where it started and what was the progress until the latest version that you have right now. Okay. And going back to everything that I have stated on the fundamentals of the drawing here, this is very important for you to like identify these parts, and it should not be missing in your drawings. Whether you're in design or in construction, these parts are here are the very basic parts of a drawing that you should not omit or forget. Okay? Because a complete drawing is a good communication. If you do not complete your drawing, hence, the reader of your drawing will not understand what is it that you want to convey. You might think that's very simple. That's very simple, ma'am. Drawing, dimensions, very easy. If you think about it, if you are a careless designer, you'll just think it's very easy. But note that when you are designing, say, for example, the one you see on the screen right now is a part, right? What if your company will manufacture 1 million pieces of this part? And then you committed a mistake. You will say, it's just a mistake on the drawing, it's fine. But the problem is, your company has already, or you forwarded it already to the manufacturer, and the manufacturer has already produced 1 million pieces of your drawing. And that 1 million pieces, let's say, for example, this part here cost $1 each. So do the math. And then it turns out that your design was wrong. There was a mistake on the dimension. So that $1 multiplied by 1 million pieces equals to $1 million. And that $1 million might be a huge loss. Not might, but rather a very huge loss for your company. So who will take the blame? Well, there's a design team, diba? So that's why that's the use of the design team, because you're not just the designer will not just produce the drawings or the parts on your own or the design of your own. It will be scrutinized by a team of designers. So you, as well as a designer, should know how to criticize other people's design. You will tell them that this is not manufacturable. This is very hard to manufacture. So in the design, you have to think about the cost, the manufacturability, the availability of materials, and of course, the importance of the design to what you are making. So I know you already know those aspects in designing, right? So as mentioned earlier by our first speaker, he patterned, or he discussed his the topic that he delivered will be helpful for your thesis. This time around, it also is helpful for your thesis in presenting drawings like this. Why? Usually when I critique or when I review thesis of students, I am very particular with the design drawings. Why? Because you are conveying the message of your design. Because if it is not properly illustrated, that eliminates your intention of how unique your design is from the other inventions. So a good 3D model and a good 2D drawing is tantamount to having to relay a good design sa inyong invention, such as if you're going to conduct, if your thesis is on designing machines or inventing machines. Okay, so I hope you pick up more of this. Moving forward, let's talk about the different drawing views. So you already know the isometric view, very easy, di ba? Isometric view immediately when you're creating 3D model. You also know about orthographic view, right? Orthographic view, yes. So orthographic view, by the way, has these two standard layouts. This one is very important. Why? Most of the time, students don't know what's the meaning of this. And probably because no one taught them. Or even engineers. You guys, you can even ask, even engineers in the industry, some of them don't know these two types of standard layout. There are other layout, by the way, but these are the two standard layouts that outstands them all. The ISO standard layout and the US standard layout. And in a drawing, in a design drawing per se, you have to pay attention to these symbols. The ISO symbol and the US symbol. It somehow looks kind of the same, right? It's just that the orientation, ma'am, of the circle, the other one is reversed. Very easy to identify, between the ISO and the US standard layout. But do you know that there is a very significant difference between this? So if you're going to use ISO standard layout, which is defined by this one here, the symbol right here, a parallelogram nga nakahigda, and a concentric circles, baka ni siya nga symbol, know that what it meant is that the view you are looking right now is that the front, and on his right is the right side, and below it is the top view. And why? Because there might be wrong interpretation of the drawing views you have presented. When you say presenting a drawing, if you look into this drawing, my first part of drawing, okay, if you look into this, I did not place any annotation stating front view, right side view, top view, because you do not do that in a drawing, technical drawing, or in a drawing. You do not label because, say for example, in this one, I'm not sure if I place in, okay, there's no symbol. That is because if you place in this one here, okay, if you place in this symbol right here, it will automatically tell you that the orientation of the view that you are seeing right now follows this. No, so otherwise, you don't need to place in the front view, the top view, so on and so forth. So pay attention to the symbol. And on the other side, on the US standard layout, this is what is commonly used in parts. I've encountered a lot of different design drawings, and all throughout my seeing of different drawings, this has been always the ones, the view or the layout, standard layout that has been used most of the time. Probably majority dyan siya as in. So what does it mean? When you see this symbol right here in your drawing, it meant that what you're seeing here is the front view. It is projected on the right side view, and it is projected to the top view. Nothing more, nothing less. That defines the US standard layout. And again, do not mix it up. Why? Because there might be cases that the interpretation of your drawing would be wrong. So know that those reading your drawings are engineers in the manufacturing field, for example. They know this as a basic. Machinists know this as a basic. So it's such an insult to engineering, or let us say mechanical engineers, if you yourself doesn't know the meaning of this. The manufacturers know, like the machinist knows what is meant, but you do not know it. Okay? Most of the time, students got this wrong. Why? In their thesis, for example, they just place in whatever view they want to place. No, they just place in isometric view, just place in top view and right side view. Just place in left side view, and then place back view. So what's the context, no? There's no context on the students like presenting it in the thesis that way. No. That is why you need to standardize your drawings and your thesis in such a manner that you follow standard drawing layouts that are acceptable to manufacturing industries, or in a sense in the technical field in general. Okay? So, hopefully, this is something you will remember. You have, if your elective teachers for CAD wasn't able to discuss this, hopefully you get it from here. Like the difference between ISO standard layout and the US standard layout, and how to properly use orthographic view. Okay, in our presentation of our design. Now, there are also other drawing views that are very helpful for you, such as the projected view. Got it? You always use this one. You also have the flat pattern view. For a flat pattern view, this is only used on sheet metal parts. So what do you mean by sheet metal parts? Say, for example, a very good example is, the back of your CPU, if you notice. I think, do you have PC at home? Or in your laboratories, diba? Or anyway, I know everyone has encountered PCs. So for your PC, the back portion of that, there is a metal part. Mga old PCs perhaps, I don't know with the new ones, if napa ba yung mga, if there is still the metal part. Anyways, the metal part at the back is just a sheet made of metal, but a sheet one. And then it is punctured, it is bended to a certain shape that the design requires it to. So in a sense, if you're involved with the sheet metal part design, you will have to place in a view that's a flat pattern view. A flat pattern view, it's like from your formed shape, from your shape or from the model that you've created, you're going to stretch it out in a flat sheet as if it's the raw material flat sheet. So that's how you present in a sheet metal design. Okay. I'm not sure if many of you knows about sheet metal. So that's another industry as well. It's a whole different designing as well in sheet metal, because there's a lot of things you need to like follow, or you need to check on sheet metal. Number one is manufacturability, because not all designs can in sheet metal can be manufactured easily. Most of the time, they are very, very difficult. There are designs that are very, very, very difficult to achieve in sheet metal industry. Okay. So moving forward, we have also the detail view. So the detail view is something you want to maximize, or you will how do you call that? Zoom in. In your term, zoom in. So you pick a smaller section and then you zoom it in, or scale it up a couple of times, so that you are going to emphasize that part, and that's the time you can dimension that small part that you have zoomed in or you have emphasized. Okay, and then is this the detail view, right? The detail view. Next one is the section view. So the section view is very, very straightforward. You cut apart, then that cut part is something you project. So you can see the cross section from this word itself, section. So you cross section. You'll be able to see the cross section of the part. And that's the time if there are needed dimensioning that is internal to the part, you'll be able to dimension it through section view. Okay. And another view is the auxiliary view. Auxiliary view is used when the view that you want to project is something not on the planar view, such as right plane, top plane, or right plane, top plane, or XYZ planes, but rather with referencing to a surface, for example. So in this example right here, this view that is projected is reference to this plane right here, cutting this plane right here. That's why you are viewing this orientation. Okay, that's the drawing view. Now I'm going to share in another to continue my discussion. All right. Have here my next part. We're now going to dive into the second part of this. We have already know the basic parts of the drawing. You have already know the basic drawing views that you may be able to place in your drawings. This time around, let's try to learn on the basics of dimensioning and how we can properly dimension, and the standard practices of how we can make our drawing technically sound. Okay, so let's start off by defining dimension. So a dimension is the science of specifying and tolerancing the shapes and location of features on objects. So once the shape of a part is defined with orthographic drawings and other views, the size information is added also in the form of dimension. But know that dimensioning comes in two types: the size dimensioning and location dimensioning, which I will be discussing in a while. Okay. Second point of dimensioning is that if your part is properly dimensioned, you as the designer has the clear intention to those, number one, the person making your part. So that's the manufacturer, no? The machinist. And your design is clear to number two, the inspector checking your part. Because again, after manufacturing your part, in order for the manufacturer to check if the produced the part that is produced is up to your design, or it accomplishes the specific, the one that you specified in your design, it needs an inspector to do that. It's a Q. That's what we call QA, or mga quality checkers, QC, quality checkers. So if you think about it, in manufacturing, such as food, diba? They manufacture food, for example. At the end of the line, and at the end of that line of the manufacturing, there is what we call a checker, quality checker. If it will check if the produced product is okay for market. This is the same with designing our parts, because if the part that is produced does not meet your specification as the designer, then it will be scrapped off. It will not pass the QC, hence it will not be used in your design. And lastly, in dimensioning, a fully dimensioned, or a fully dimensioned part, or a completely dimensioned part, has three elements: the graphics, what that is, the drawing views, the dimensions, tells about the sizes, so on and so forth, and the words or the annotations. That's your notes. So make sure that your drawing has, of course, those elements, as of course discussed earlier. So now, this is what I'm telling you about size and location dimensioning. The size and location dimensioning are two different dimensions, mainly because of their purpose. So for the size dimensioning, it refers to the size of a certain geometry. Say, for example, the radius of a circle, diameter of a circle, the length of a rectangle. It tells you the size, the width. But the location dimension will tell you, for example, in a big part, you have a cutout hole. So in that part, where is your cutout hole located? And again, you will have to dimension that one. So I'll show you later on how you can do size and location dimensioning and make your drawing sound. Okay. Know that a well-dimensioned part, again, I will always repeat this one, will communicate the size and location requirements for each feature. And I may say each feature, whatever the feature you added into your design, must be communicated properly. Okay. Now, so in the presentation of your drawings, you have what we call this, the unit of measures. It's very important that you note what unit of measure you are going to use. Okay. In certain drawings, like industry drawings, the drawing block, you remember the drawing block? The drawing block sometimes contains a statement wherein they use this unit of measure. So, for example, unless otherwise specified, it's actually presented most of the time, presented that way. Unless otherwise specified, dimension is in, say, for example, meters or in mm. In our case, usually we use mm. But then, if you are not going to use mm in your drawing, that's the time you place in your notes your dimension unit of measure. Okay, so in a unit of measure, in a drawing used in American industry, all dimensions are in inches unless otherwise stated, because that's American industry. America, they use that one. So most countries outside of the United States use the metric system of measurement, or the SI, International System, or SI units, which is based on meter, millimeter, centimeter, outside of United States. But in United States, they use inch-pound system, IPS. So the SI system is being used more in the United States because of global trade and multinational company affiliation. Ma'am, it's very contradicting. The first statement and the third statement is very contradicting. Why is that so, ma'am? Okay, here's the thing. Here's the difference. If there is an American industry, American company operating in America and nowhere else in the world, only in America, they use the IPS, inch-pound system. But if there is a multinational company operating in America, operating in other countries, even if that is an American company, they will use the standard, the SI system, or the International System of Units, the SI, which is based on meter. Okay. Probably you might be confused, no? But in some cases, Magod, in some cases in general, it will always depend on the company. It's just that, is there a standard saying that since it's in America, they should use IPS? There's none actually stated, but this is the trend, or this is actually what you see in the industry right now. That when you see a company that's in America, operating in America only, they use that unit of measure. And when there is a company that's operating in different countries, they will always use the SI system. So occasionally, sometimes, other companies use both the SI and the English. That is why later on I will show you that there is where you can place in 2 dimension both SI and English units in 1 dimension. There is actually. So by the time that you encounter drawings such as that one, you already understand, okay, I understand this. The placing is, this is English, this is SI. So you will not confuse yourself when you are reading the drawing themselves. Okay? What do you mean by that? Here, for example. So these are the different methods of placing the unit of measure, but try to look into this. 127 and 5. Does it mean 127 and there's a bar and there's 5.00 below? Does it mean it's a fraction? Does it mean it's a fraction? No. I'm not used to know there's no interaction with the crowd. Anyways, it doesn't mean that it is a fraction. So when you encountered a drawing such as this one, guys, that is not a fraction, but it's a different, there are 2 units of measures in 1 dimension. 1 being metric and 1 being SI. Simple as that. So do not interpret it something na 127/5 is the dimension, and you will interpret it literally something as you really divide the numerical and the answer to that is the dimension. No, that's not the case. So by the time you encounter these kinds of dimension, please do know that, okay, I learned that from Ma'am Reg's seminar na that is a 2 unit of measure in 1 dimension. So you will not be ignorant of that type of dimensioning. Okay? Another method is the bracket method. If you notice that there are 2 dimensions or there are 2 numericals, one with bracket and one with not, that is also another way of presenting 2 unit of measures in 1 dimension. The other one being SI and the other one being English. Okay? So on and so forth. Now, we have to be acquainted with the different terminologies in basic dimensioning. Okay, let us first with the first part here, the dimension. Number one. This one. Number 1 is the dimension. Clearly, as it says, dimension is the numerical part. Number 2 is the basic dimension. The definition of basic dimension is the numerical value defining the theoretically exact size of the features. Meaning to say that theoretically that is what you intend that dimension to be without any tolerance. So you want the manufacturer to really achieve a theoretical size specified in this numerical value. That's what you're trying to convey. Another one is the reference dimension. This one here is the reference dimension. Why do we call this a reference dimension? So you might notice sometime that there is a dimension when you're doing AutoCAD or when you're doing SolidWorks or Inventor. I don't know what you're using in your schools right now. But when you dimension a part that it is not needed, most of the time, not most of the time, but it automatically it will dimension wherein it places in a parenthesis within the dimension. What it meant is that it is a reference dimension. What do we mean by reference dimension? A reference dimension, in a sense, in generally, you don't need that dimension anymore, but you chose to place it, to still place it. Say, for example, why do you think this dimension is not needed? First dimension, this one. This is able to identify the dimension from this part, from this edge right here to the center of the whole cutout. You have that dimension. But adding in the radius of this one here, you'll be able to add it in. When you add it in, this one here, you already have the entire dimension here. So adding in, okay, adding in the reference dimension is actually not needed anymore because you have already identified two dimensions that is able to identify the entire height. So in a manufacturer point of view, the reference dimensions are not checked. Why? What do you mean are not checked? So the inspector of your part will not check it anymore because it's only in your drawing, it is only specified as reference dimension and not something that the inspector needs to check. So again, if that is the case, so less cost, no? Because there is one less dimension that the inspector will check. Okay? Don't worry, we'll make this fast. We have the dimension line. This is the dimension line. Where is the dimension line? Here. This is your dimension line. This is the extension lines wherein, for example, it came from this edge right here, extended to there. This one is your dimension line, extension line rather. This one is your dimension line. Okay? Next one. You have your arrows. Number 5 is arrows. 6 extension line. 7 is your okay, visible gap. So if you zoom this in, or automatically, by the way, when you're using software such as SolidWorks, Inventor, what other 3D model, those are the tools that I use. Creo parametric. When you're creating 2D drawings, it is already programmed in 2D drawings that it will automatically show a visible gap. However, you can still modify the distance, for example, of the visible gap by redefining your features or your standards set in your application. So it's up to you to explore that one, but there is a section in your 2D drawing where you can change the visible gap. Let's say increase the visible gap or decrease it. There's everything that you do in a 2D drawing actually can be modified as to your preference. It's just that by default, it is using a standard values from a standard, say for example ISO. So it's following, for example, ISO or from ANSI, something like that. Okay. Now we have limits of size. Where's that limits of size? Number 9. Okay. Limits of size. When you encounter a dimension such as this, know that this is not. If you look at it closely, there's no bar here, right? Or there's no slash or bar, but there's 2 dimension. However, that dimension is only 1 unit of measure. For in this case, I think this is in English, so in inches. But the 2 dimension shows there's the extents of the tolerance. This time around, there is a dimension which you have already an applied tolerance. So what is shown there is a lower tolerance and there is a upper limit and there's a lower limit. Say, for example, you say a tolerance of, it's specified here, the dimension supposedly, say, for example, is 2.5. It has a tolerance of 0.01 plus minus. So we say plus minus, lower limit is, of course, the lower dimension. So instead of placing in the tolerance value plus minus 0.01, what it what this dimensioning is showing to you is already the maximum allowable dimension and the minimum allowable dimension. So that's how you interpret these kinds of dimension. So if the manufacturer now manufactures your part and the inspector checks this one, so let me ask you, if the dimension he measured is 2.495, is it acceptable or not? Anybody can answer? So, wala ba talagang interaction with participants here? So I hope you answer in the streaming platform that you're in right now. If you can show probably the comments, right? Something like that. Question that, right, diba? My question is, yeah, thank you, JM Kalales, no? You're correct, acceptable, because the 2.495 lies within 2.49 and 2.510. So when the checker or when the inspector checks your part and that is what he measured, and you'll say accepted. So move forward to the next process. Okay, so know that when you encounter these dimensions, you will immediately think, okay, this is with tolerance, upper limit and lower limit, right? Now, going back. So that's one way of presenting the limits of size. Another one is the plus and minus dimensioning. Here is the one. This is what I told you a while ago, that when you place a dimension and you place a plus and minus or upper limit and the lower limit together with dimension. So let me ask you, anyone can answer. If we're going to identify the maximum allowable dimension to this, what would be the value? Applying, of course, the tolerance that is stated there. What is the maximum and what is the minimum allowable dimension? Can we have your PDF? Yes, I can share to you this PDF for you to learn or to review. Okay? Again, no, I'll ask a question. Who can answer? If I'm going to add in the higher and lower limit of the tolerance, what is the maximum allowable dimension? So first, the maximum. You answer. Anybody can answer? 1.282, correct. Okay, you just simply add in the 1.25 by the upper limit, 0.032. How about the lower, 1.240? Okay, correct. The minimum is 1.240. So that's the max and the minimum values you are able to manufacture your part. Okay? See, I hope you're learning, no? Because I will be very happy if you'll be learning from this topic, because not all electives can teach this one in your schools, because most of the time dahol sa oras or hindi na ma-include ng teacher sa discussion ito, which is class. This is very important for you to really know this one, because this is an application in the industry. You will really encounter this sometime when you're engineer already, and through this you'll be able to learn na hindi na tayo maging ignorante, no? When we encounter that one, we know already how to read the drawings, and we are, kahit hindi man tayo expert, at least we know the very basic, right? So yeah, let's further continue. So plus and minus dimensioning, diameter symbol, radius symbol. Okay, here's the thing. Probably for mechanical engineering students, you already know the diameter symbol, right? Do you know what the diameter symbol is? So, hindi yung theta, ha? Baka ma-interchange nyo sa theta. So, there is a Greek letter. I forgot the Greek letter. Anyways, that's this one here. This one here shown in the screen. That is the diameter. And in the drawing, that's the diameter symbol and radius is denoted as R. Okay. I know you already know that. But alam nyo ba, sa ibang engineering discipline, they have trouble identifying between diameter and radius. That's actually my struggle, everyone. I mean, you guys, I know you already know this one because you're mechanical engineering students. But most of the other engineering principles, hindi nila alam kung ano yung symbol ng diameter. Diyos ko, naloloka ako kasi I'm handling CAD subjects, not just for mechanical engineers, but for all engineering disciplines here in the university. And I'm really shocked at that revelation na hindi nila alam, kahit simple as diameter symbol. So I hope yung mga mechanical engineering students natin dito alam kung it's a very, very easy thing to identify, no? Para hindi naman tayo mahiya or in public, or let us say, mahiya tayo na hindi natin alam, right? So, kung hindi nyo alam, okay lang. At least you know now, okay? All right, moving forward. So, what is the fundamental concept of making a 2D drawing of a certain part? Simple lang. What is that information that you need to make the object? Because again, di ba sabi ko kanina, over-dimensioning the part can cost more, and under-dimensioning your part, you will not be able to relay your information to your manufacturer or to the ones reading your drawing. So, ma'am, paano ba talaga namin ma-identify kung tama na po yung aming mga binigay or nalagay na dimension? Simple lang, ito lang isipin nyo. Think as if ikaw yung gagawa ng part. Pag ikaw yung gumawa ng part, tapos hindi mo alam kung paano ma-achieve ang certain area kasi wala kang dimension doon, meaning kulang yung dimension mo. So that's just a very, very fundamental concept when you are dimensioning. How will I be able to form the part? So parang, let us say, after you have made your 3D model, you're now going to make your 2D drawing. When you're making your 2D drawing, in order for you to dimension, bumalik ka from zero. As if you're creating the part again. So if you're creating the part again, what are the dimensions that you use to create, say, for example, this section of the part, this section of the part. And you going down until such a time that you'll be able to complete the dimension of your part without having to over-dimension and under-dimension. Okay? So, I still have the time kasi I still have a couple of slides left that very important thing for you to learn. So again, balik na naman tayo sa size dimensioning and location dimensioning. So this is the very example that I'm telling you how to properly dimension your part. The size dimension, say for example, this is a cube. Say this is a cube. Tapos in a cube, magka-cut out ako ng hole. May butas siya sa gitna or somewhere. Okay? First thing I need to do is identify the size of my hole or yung butas ko. Then, so I have already identified a size. And then identify ko rin yung size ng cube ko. Identify ko rin to. Length, height, and width niya. But then, question, saan natin ilalagay yung hole ko? It doesn't mean na yung hole na ginawa ko, yung butas na gagawin ko, immediately sa center yon. Why? What if sa laki ng part mo, hindi pala sa center dapat yon, but in a certain area? So how will you convey the information na hindi yan center dito yan ilalagay. Sa ganitong na part na to ilalagay yung butas natin. So what you do is you dimension the location. In a sense, in this case, pag may circle ka or may cutout ka, may hole ka na circular in size, you place in is center mark. Ito center mark na to. And that will denote now, gawin mo yung reference para malagay mo yung location niya. And here is the important thing when it comes to location dimensioning. Wag na wag tong kakalimutan. When you're placing in a location dimension in a 2D drawing, always remember that there should be an X value and a Y value. Parang nag-create kayo ng invisible Cartesian plane, X and Y axis, and then dinadimension nyo siya according to the X, reference to the X axis, and reference to the Z axis. Coordinate talaga. Coordinate points. Para it will serve as your location. Di ba sa CAD, mayroon din yan sa CAD eh. XYZ sa AutoCAD, meron yan. XYZ, saan sa model space mo, ilalagay mo siya. In AutoCAD kasi, it's usually used in construction talaga and everything. I used AutoCAD before in the industry with specific coordinates talaga, like Earth, yung talagang geographical coordinates talaga. Kasi it's a project where it traverses exact points along a map. So, madali yun sa AutoCAD. But in designing, 3D designing, you have to locate, say for example, this feature, itong butas na to a certain reference. Okay. Now, I will talk to you about reference later on. Paano ba gawin yan efficiently, yung pag-dimension natin using, of course, location dimensioning. We'll know later on. Okay, these are some size and location dimensioning on different, paano siya gawin in different types of geometry. So, may radius, may height, so on and so forth. Skip na natin yan. Okay, ito na yung sinasabi kong rectangular coordinates and with the use of the datum. Okay, ito. So, in a sense, if mayroon kayong part na ang daming feature, tulad nito, 3 butas sa isang plane. So, how do you dimension that one? So, there are 2 ways na mag-dimension ka. It's either yung ordinate dimensioning or yung dimensioning simply stacking dimension. However, ito lang yung tatandaan nyo. Si stacking dimension kasi, what I meant by stacking, say for example, this one is a dimension, dimension natin sa taas. This one is a dimension. Sorry ha, kasi hindi ako naka-tablet right now. I'm using my PC. Ito yung dimension. Ito yung dimension. Okay. Say for example, iba-iba yung dimension na yan. No. What is the problem in this type of dimension is that kapag may tolerance ito, yan, hindi na ako makaride, at ito may tolerance din, at ito may tolerance din, pag nag-add up yung tolerance mo, you will not be precise on this location. Pag may tolerance. Kaya when you are referring to or when you are applying location dimensioning, this stacking dimension is not preferable. Bakit ba? Kasi ang tolerance nyo nagsa-stack din. Okay? Sa stack din yan, which is not good entirely. Okay. Bakit ba? Let's dive into the difference. Bakit? Say for example, itong first location ng hole is 30. Diba? Second location ng hole is 45. Third location ng hole is itong 75. Pag ginawa natin, clear ko muna yung, paano ko ba i-clear? Ayan eh. Okay. Yan. Okay. Now, ito. I-base natin ito sa last hole. Sa dimension na ordinate dimensioning, from a certain origin, 0, 0, yung third hole mo, yung dimension niya is 75. Now, let's assess it or let's dimension it yung nakastack. Say ito, tsaka ito. Add natin. Ito si 30. Ayun, hindi talaga ako makasulat dito. Anyways, Sanay sana ako 30 ito. Itong part na to is 30. Itong part nito is 15. At itong part na ito is 75 minus 45, that is 30. So, 30, 15, and 30. But add in a tolerance na 0.1 each. Upper. Let's just consider upper limit para hindi na maguluhan. Let's just consider upper limit tolerance. May 0.01 tayo na tolerance. So, this 30 becomes 30.1. This 15 becomes 15.1. And this 30 becomes 15.1. Tama ba? 30.1. So, add natin. 30.1, 15.1, plus 30.1. Magkano lahat? Kung i-add natin. It will total to 75 point. May mag-answer ba dyan? May nakikinig pa ba? To total to 75 point. Ano nag-answer? Yan. Si Fritz. It will total to 75.3, di ba? Yan, thank you. Yan, si Jomar, si Adrian, thank you. It will total to 75.3. So, in that case, tingnan natin yung ordinate dimension. Si ordinate dimension is 75. And add in a tolerance na 0.1. Magkano? 75.1. 75.1 versus 75.3, is it a very big deviation to the original dimension? Yes or no? Ang awkward na walang sasagot. Baka may sumagot dito, ako lang mag-isa sa office ko. See? 75.1 and 75.3 is sobrang layo. So it's a yes, sobrang layo. It's not accurate anymore. If you add a tolerance, tapos nagsa-stack na siya. So pag nag-stack siya, hindi na siya precise, accurate sa intention mo, which is 75 sana yan, tapos may tolerance ka na 0.1. Eh, ang layo na nun, 75.3. Diba? So that is why we go back to the idea na pag naglagay tayo ng location dimensioning, always use ordinate dimensioning. Because it will eliminate the stacking of your tolerance. Alam nyo, maganda sana, itatopic natin is yung tolerance analysis talaga. I've learned a lot from tolerance analysis talaga. It's a good topic. Though I'm not qualified to teach you that one because I myself was a student of tolerance analysis na it's quite very good talaga. It's good for you to know that one. Hopefully you can find a speaker who can discuss about tolerance analysis. Sooner or later, kontak ko yung seniors ko sa design team namin before, ang galing nila mag-tolerance analysis as in. Okay? Anyways, so going back to location dimensioning, that's important for you to use ordinate dimensioning. Okay? So, pay attention to the right side here, etong part na to. This is much cleaner. Guys, cleaner siya, di ba? Kasi it uses a tabular form wherein it says here that say, hole A has a hole diameter, ang size dimensioning ito, hindi na siya naglalagay ng katulad ng ganyan, yung may arrow pa na radius or dimension niya. He just places it in tabular form. And when it's already in tabular form, all that's left for him to do or her to do is to add in the location dimensioning. This time, mas cleaner siya kasi hindi siya gumamit ng arrowheads. However, again, it depends on the drawing standard ng application na sinet mo. Kasi different si ANSI, different si ISO. Marami pa yung may Japan din na system, something like that. But most of the time, we use ANSI. Yun lang ha. What we use most of the time, itong mga arrow na to, is ANSI. Yung iba is ISO. Parang yung si ISO walang arrowhead. Something like that. But regardless, that's still a dimension standard. Sa ME, sa mechanical engineering, ito yung gamit natin yung standard, yung may arrowhead talaga. Okay? Yung difference lang nito, everyone, is just that it doesn't contain this dimension line. It's just the extension line and immediately the numerical value. Okay? Nevertheless, it's still an ordinate dimensioning which is used for location dimensioning. Okay. Now, dito na tayo, standard practices. This would be the last part of my discussion, the standard practices. And this is very important kasi ito dapat na tandaan nyo when you're doing dimensions. No? Number one is the placement. Pag naglagay kayo ng mga dimension, huwag maglagay dito, class. Like, for example, ito, huwag ilagay dito sa dulo. Always align your dimension to the center. Yung mga student ko, ang titigas ng ulo nga eh. Pag ganyan, nag-check ako, minus yan. Minus yan sa grades nila. Kasi dapat, you follow the placement, standard practice of placement wherein you have to place it in the middle. Ma'am, is there such cases na pwedeng hindi sa middle? May cases na hindi natin nilalagay sa middle pero may reason bakit hindi natin nilalagay sa middle. And I will show you later on. Okay? Ayan. So aside from placing it in the middle, there's also a standard spacing that you need to follow. So most of the time, sa mga application natin, AutoCAD, Inventor, Autodesk Inventor, Creo, or SolidWorks, may standard na siya, may automatic snapping siya na pag nag-reach siya ng minimum na 10 mm from your edge here, nagsasnap yung dimension mo. But regardless, kung walang feature na ganyan yung application mo, you have to remember that the first dimension that you add in from your model edge, or yung feature mo, edge nito, should be a minimum of 10 mm. And the succeeding now, minimum is 6 mm. The term there is minimum. So, ma'am, pwede bang mas lumayo? Pwede. Just as long as hindi, ganito, just as long as hindi mo nilagay dito na part, ang layo-layo din naman. Common sense lang din naman, no? But again, the minimum is 10 mm, the succeeding is 6 mm. And kanina, I mentioned about the visible gap. It is a must that there should be a visible gap. Kahit ma-adjust mo yan, yung distance niya, ma-adjust mo yan. The idea is dapat may visible gap siya. Okay? And itong distance from your arrowhead to the end of your extension line is dapat at least or at most or at least 2 mm. Or 2 mm na lang para standard. Again, sa mga software nyo, minsan or most of the time, this is already predetermined or preset sa software nyo. Okay. When you're also doing dimension, you have to remember that you have to group your dimensions. So, tingnan niyo sa screen niyo right now, may correct way of dimensioning and merong mali na way sa dimensioning. Number one, itong maling dimensioning natin dito kasi ito yung dapat tandaan niyo. Yung dimension niyo nasa loob ng drawing view niyo or sa part niyo. Which is, guys, this is a mortal sin when it comes to drawing dimension. Bakit? It should not be placed inside a drawing view. Dapat dimension nyo is always outside of your view, such as this one here. Kita nyo? Diba? Ang linis tingnan, ang ganda tingnan. And it's also grouped in one place. Hindi nyo siya lagay ng, kung basta lagay lang, di ba? Like for example, itong dimension to, lagay nyo dito, tapos meron na nito. So that's not how it goes. Lagay mo muna siya bago ka maglagay ng mas malaking dimension. Again, common sense lang talaga. Dapat may pagka-OCD ka dito. Slight lang naman, class, na dapat may pagka-OCD kayo na dapat properly organize kumbaga yung mga drawing nyo or yung mga dimension nyo. Okay. Ito na sinasabi ko kanina. Ma'am, pwede ba hindi i-center yung dimension? This is the case why pwede siyang hindi i-center. Say, for example, si staggering. Kita nyo naman, magkasunod-sunod yung dimension natin. So, in this case, kasi magkalapit-lapit lang siya. Ang alangan naman, masyadong malayo yung distances niya, di ba? Pwede yung i-offset siya. But this time, yung offset niya, of course, gawin din nating organize as you can see in your drawing, in your screen right now, di ba? Ang ganda tignan, ang linis tignan ng drawing natin, ng dimension natin. Kasi it is arranged properly. It is staggered properly from the least to the greatest dimension. Okay? Next, extension lines. So sa extension lines class, pag hindi magkasya na talaga or parang pangit na tingnan, kung si extension lines ipipilit mo talaga sa isang area, pwede mong gawin ito, itong projected extension lines. Paslan, pwede yan, that's accepted. Paslan. Pero again, you will have to specify that one in your dimensioning feature. Okay? Next one. Ito. This is a usual problem or this is a usual mistake of students or even engineers in the industry. Nakikita ko to most of the time na mali. Why? Pag si arrowhead mo nag-i-intersect with extension line, dapat si extension line i-break mo siya. Putulin mo si extension line na dapat si arrowhead mo is naka-highlight. Kung sa parang si arrow is naka-bring to front yung arrow mo, yung extension line mo is nasa back end. And bakit i-break natin? To emphasize nga dapat si arrow hindi siya ma-break kasi arrow siya. Whereas si line, extension line lang siya. So ma'am, paano ba yan gawin sa CAD or sa drawing namin sa SolidWorks? Mayroong feature nan. Sa mga application nyo, may mga features sa dimension nyo na i-break nyo yung extension line when it traverses. Kasi meron kasing ibang dimension application na hindi siya automatic. So you have to manually break the extension line. That is why it's important for you to identify. See, for example, ito, nag-traverse siya sa arrow, so immediately, i-break mo siya. Pero tingnan mo yung isa dito. Tingnan mo yung isa dito. Hindi siya break kasi yung extension line is traversing through a dimension line lang. So, hindi siya nag-intersect with arrow. So, you don't need to break that one. Including this one. Si extension line is traversing to the feature. I-break mo ba? Hindi, of course. Diba? So, just know when to break your extension line. And that is only when your extension line is intersecting with an arrowhead. Okay? Important yan ha. I hope you remember that one para when you produce drawings later on, you will remember that hindi yan pwede. At pag sinabing may nagsabi sa inyo na hindi naman yan kailangan, di sabihin nyo, hindi kasi kayo nakapag-attend ng seminar na si Ma'am Reg yung speaker, hindi nyo alam na standard yan. O, di ba? May mapagmamalaki na kayo sa iba. Okay. Anyways, so extension lines, no? So center lines used as an extension line that is acceptable. So when the location of the center of features being this dimension, the center line of feature used as an extension line. So pwede yan. Okay. Ito, limited standard practices when you show the limited length of areas. Or areas. So, say for example, sa view nyo, hindi nyo, like sa drawing view na yan, itong drawing view na to. Tapos, crowded na yung drawing mo. So, let's say orthographic view, front view, right side view, and top view. Tapos, hindi nyo mapakita yan kasi nasa, for example, nasa bottom view siya. Sa example nasa bottom view siya. Pwede nyo siyang lagyan ng annotations or section view ito. And then, ilagay mo siya sa section view na parang pinoproject mo siya na from bottom view, pinoproject mo siya sa isang section view wherein you can detail that part of the drawing. Yan. So that's limited areas or the limited lines. Okay, malapit na. Okay. So reading direction of your dimensions. There are two reading dimensions. We have unidirectional and aligned old standard. Itong aligned old standard, I think this is associated with the ISO standard dimensioning. And itong si unidirectional is aligned with the ANSI. Regardless, whether it's unidirectional or aligned old standard, that is still acceptable kasi standard yan. It's just that, kung titingnan nyo, mas pleasing to the eye si unidirectional kasi hindi ka na magtitilt-tilt ng drawing mo para makapagbasa ka ng dimension kasi it's already normal to the viewpoint mo. Which is, I would recommend to everyone, not really necessary, but I would recommend to everyone na pag nag-dimension kayo, use the ANSI standard para immediately mag-unidirectional standard yung dimension mo, hindi na mahirap basahin yung dimensions mo. Okay? You also have to, importante to, view dimensioning. Why? You have to dimension in such a manner na yung view na ginagamit mo right now for dimensioning will tell you the true form of your model. Kung baga, kung anong view na yan, kung anong applicable na dimension, yan yung ilagay mo. Okay? That is associated because, say for example, if a front view mo yan, let us say top view to, tapos if a front view mo, in the front, sa front view nito, ganito lang yan. Tapos may ganito. Right? You cannot tell that this part here is a cutout pag nasa front view yan. If this is the top view, this is the front view, you cannot tell that this is a cutout. So where do you dimension this part here? Of course, it should be in the top view and not this view here. Bakit? Pag dimension mo siya ganyan, dyan, itong part na to. So question, what do we mean? Anong ibig sabihin nito if you're dimensioning it in the front view? You cannot understand kasi hindi mo ma-figure out yung shape niya. Bakit mayroong dalawang linya dyan, hindi mo naintindihan. But when you look at the top view, kaya pala may ganito kasi may cutout siya dito. Then you dimension the cutout part where you dimension the cutout part to the view that mostly projects the true form niya. Okay? Right. This is, by the way, out of scale dimension. So, si out of scale dimension, pag nakikita nyo na may dimension tapos may underline, isang dimension may underline, meaning out of scale siya. Meaning, hindi siya according to the scale that you specified. Ang dimension niya is probably scaled up or scaled down. Kasi hindi siya nakascale according to the dimension that you currently apply to the rest of your drawing. But, regardless, very seldom yun na-encounter to. Pero pag naka-encounter kayo ng ganito, at least you already know that is an out-of-scale dimension. Okay? Repetitive features, importante din to. Why? If you have repetitive features such as this, na itong hole na to, at yung apat na hole na to, isang size lang, gawin yung ganito, or dimension yung ganito. 4x, meaning 4 times this dimension value. Bakit? So you don't need to add in dimension na isa-isa. Bakit? Ang pangit tingnan ng drawing nyo. Over-dimension na rin yan. Why? Because there's no other whole features na katulad nito. Ito lang. So, dapat lagay nyo 4. Simple as that. Okay? Now, ito. Holes. Make sure si diameter, alam niyo naman, si diameter traversing to the center. Okay? Baka maging ganito. Diameter nga, pero hindi siya nag-traverse sa center. So, pay attention din ganyan. And then, we also have here how to dimension chamfers and slotted holes. Most of the time, yung mga application nyo, SolidWorks, Inventor, may automatic na yan na magda-dimension. Pag create nyo yung part nyo according to a standard hole feature, pag-dimension nyo ng ganyan, nito, it will automatically show. Regardless, if it's not in automatic hole made, ang gawin nyo is, for chamfers, do this type of dimensioning. Pwedeng angle, tsaka yung diameter, outer diameter, or outer diameter, tapos angle ng dalawa. Ganito. 2 ways. For slotted hole, okay, pay attention. Si slotted hole, tatlong ways lang talaga. As in, itong nasa-show nyo right now, this is how you dimension a slotted hole. Number 1, yung rectangular extents niya ng slotted niya, dimension, tapos yung radius ng curve niya, or nung end-to-end niya. Second way is center-to-center distance, and then yung thickness niya, tapos yung radius. At third way, eto, is just pointing out the rectangular size and the radius. Somehow the same as this, pero in annotation, leader type lang siya. This is how you dimension a key seat. So, alam niyo naman kung anong yung key, right? So, for the key seat, you may dimension it as this. May diameter ka, may from bottom to the flat surface of the keyhole, tsaka yung thickness ng keyhole. For the keyway, ganito din. I'll give you the PDF later on. I mean, I'll give the PDF to the organizer so that it can be shared to all of you. Magpapabayad lang siguro ako 50 pesos per copy. So, magkano ba yan? Ilan kayo lahat dito? The joke lang. Anyways, yan, concentric circles, as shown kanina. Arcs, this is how you dimension, detail dimension. And then, for screw threads, so most of the time, screw threads are automatically dimensioned when you click the hole or the threads that you have applied it to, and then yung application nila will do the work for the screw threads. Okay? The grooves, this is how you dimension. Pay attention na lang yan. And then ito, a technique that is mostly used or is very helpful for everyone doing 2D drawings class is you will have to contour dimensioning. When you say contour dimensioning, notice the difference between these two here. The correct one and the wrong one. See? Ang radius niya, dito niya dinimension. Nakikita nyo bang mayroon siyang cutout na hole or may curve? Diba? Wala. So, ito dapat. Itong nakikita natin na naka-cutout siya na naka-radial or naka-circular. So, dapat dyan natin ilagay. O, top view natin. Dyan natin ilagay ang ganito. Whereas dito, ito yung sinabi ko ni yung view dimensioning, dito niya nilagay. How can we interpret these lines here kung hindi naman natin alam kung ano itong geometry na to? So, dapat, this one is the right way to do so. So, contour lang. Follow the contour of your model. So, kung saan yung magsa-show ng true shape ng model nyo or yung ginawa nyong part, doon nyo ilagay yung dimension na needed for that. At huwag ilagay sa ibang view. Okay? This one here. In order for you to dimension completely, ito yung sinabi ko kanina na para hindi ma-underdimension at overdimension, this is a technique that can be used, that pwede nyo gamitin. That is the geometric breakdown. Say, for example, itong model, itong part na ito, i-chop-chop natin siya into sections. This section right here, this section right here, this section, and this section right here. Tapos pagka-chop-chop nyo yan, that's the time i-identify nyo kung ano yung in the dimension nyo dito, dimension nyo dito, dimension dito. And that way, hindi nyo makakalimutan ni isang dimension. You will dimension it correctly and precisely. Okay? And then, here are some dimension guidelines that you have to understand or remember all the time, no? Number one, every dimension must have an associated tolerance, and the tolerance must be clearly shown on the drawing. So if in case walang yung dimension niya is walang tolerance kada dimension, usually may tolerance yan, general tolerance na ilalagay sa drawing block or sa title block nyo. May talagang general tolerance siya. Kasi hindi pwedeng walang tolerance, ha? Kasi sa manufacturing side, if you say there's no tolerance, walang tatanggap niyan. No manufacturing company will accept to make your part if walang tolerance yung design mo. Kasi kahit gaano ka-precise yung paggawa, meron talagang magiging maliit na deviation from the exact theoretical size na gusto mo. Okay? Ito kanina, avoid over-dimensioning. Double dimensioning a feature is not permitted. Dimension should be placed in the view that most clearly. Ito yung discuss ko na to kanina. Manufactured with gauges codes. Ito, manufactured to gauges or code number shall be specified by numerical values. So, ito, unless otherwise specified, automatically, by default, yung angles natin are assumed by 90 degrees. So, if it's not in 90 degrees, that's the time i-dimension nyo siya. Pero kung naka 90 degrees siya, no need to dimension that one because by default, you have to understand by default that the angle is 90 degrees to a certain extent. Okay? Dimensioning to hidden lines should be avoided whenever possible. Hidden lines are less clear than visible lines. So on and so forth. Okay. Na-discuss ko na to lahat. And lastly na lang siguro, no, kasi hindi ko nalagay sa slides ko. Have you been making your, may engineering drawing na ba kayo prior? Di ba? Nakapag-take na kayo ng engineering drawing. Ito yung common error ng mga students. Ito ha. when they're creating the drawing, they use small case, o yung mga annotations, paglagay pala ng small, yung annotations or notes, gumagamit ng small case letters. Is that correct? Yes or no? I believe there's a delay, no? But when you're creating engineering drawings, is it correct when we say when you're using small case letters? Yes or no? Yes. No. Ang answer dyan, no. Class or guys, in an engineering drawing, there should not be any small case letter. See, yung mga sagot nyo nga, di ba? Yes. Di ba? Just know that ito dapat yung takeaway, very takeaway nyo. Pag naka-encounter kayo ng drawing or pag kayo gumagawa ng drawing, never ever use a small case letter in a technical engineering drawing. Everything should be all upper case letters. Capitalize lahat. Okay? So, hopefully, isa kayo sa mga matututong na that very, very, very basic na dapat nating tandaan na when you produce drawings later on, it should not have a small case letter. Yes, engineering lettering are all capitalized, diba? So if you remembered correctly, yung mga architects na nagtuturo natin sa kanila, diba hindi tayo yung engineering lettering, walang small case letters class. All capitalized yun. And that is because in an engineering language, there's no such thing as small case letters. Okay? So remember that one, ha? Hopefully when I encounter in the future drawings na produced by you, dapat technically sound siya and following standard talaga. With that, I end my discussion. Medyo napahaba tayo. The university is closing and I'm still in the university right now. Anyways, if you have question, fire it away.
Thank you so much, ma'am, for that wonderful talk. Like, it's really, really very interactive, though there are some technical difficulties. Pero we really learned and love your presentation po, ma'am, regarding with this engineering drawing din. Lalo na, we take this parang when we were first or second year pa. So, magandang din siya. Parang naging siya sa foundation din siya on our side. So, thank you very much, ma'am. So, and now, we shall open our questions regarding engineering 𝗏𝗏𝗏 presentation. We will be having our open forum. Should you have any question regarding the topic of the second talk, you may type in your question on Q&A box. Please follow the format, full name, school, and questions. So yun guys. So please send your questions now and then Ma'am Rain will entertain you po.
It's actually Regine, yung singer. Regine.
Oh, yun.
Ayan.
Ma'am Regine.
Ayan. So yeah, you can fire away your questions. No, ask me. I'll answer to the best of my ability. Hindi ko naman alam lahat-lahat. No? Okay. Any questions? So tomorrow, while waiting for your question, I believe tomorrow, magdi-discuss kasi kayo ng 3D modeling, right? So, supposedly, yun yung mauna yung 3D modeling. Pagkatapos nun, itong topic ko about 2D drawing para package talaga, no? Yung pag after nyo ng 3D modeling, gawa kayo ng 2D drawing, ito na. But anyways, regardless, nauna to, walang problema. And tomorrow, pag nag-3D model kayo, by the time, you already know how to convert that one to 2D drawing from your 3D model. Yeah, questions? Yung questions about PPT, yes, I will give it to the organizers. Siguro 10 pesos na lang per copy. No, kidding aside. Joke lang ha. Joke lang yan. Huwag nyo yung seryoso. Bigay ko sa mga organizers for them to hand it out to all of you.
Ma'am, hello po.
Marami bang
Ako
natutunan?
Ma'am, ako
Yes,
personally may question. So,
Sige,
yun po. Yung question ko sana, ma'am, parang what are the common best practices that engineers should follow when creating design and drawings to ensure na comply siya with the standards po?
Ito yung talagang pinaka, on top of everything I've said a while ago, ito yung pinaka dapat tandaan nyo lang. Be organized in your drawing. Yun bang parang Japanese way of presenting something na systematic siya, organized siya. Parang may OCD. You arrange everything as if it's well, well coordinated with each other. Wag niyo siyang i-dimension or wag niyong lagyan na wag niyong gawin yung technical drawing or yung drawing niyo yung parang ang dami-daming ang dami-daming going on sa isang sheet. So if you cannot do or you cannot communicate or present everything in one paper, one sheet, you're not limited to only one sheet. So make another sheet or another drawing file na continuation ng ginawa mo para mas ma-clearly ma-portray mo yung communication mo. Pero of course, may cost kasi yan. The more sheets, the more din yan expensive. So you have to balance out lang the elements in your drawing na kaya nga sinasabi ko sa inyo na you have to be may OCD kayo kaunti nito kasi wag kayong mag-settle na parang okay na yan, basta na dimension, wag ganyan. You have to check every one of it if it's placed nicely and neatly, and then if it's complete. Yung aspect talaga ng engineering design, when you're working in a design team, marami kayo, di ba? So, ang mangyayari niyan, you as the designer, ipapasa mo yun sa ibang members or ng ka-teammates mo, and yung ka-teammates mo will serve as your checker. Check nila. Iko-comment nila, may mali ka dito, may okay ka dito, parang ganyan. Vice versa, pag sila rin ang may design, ikaw rin yung mag-check nun. So, ikaw yung fresh eyes na magtitingin ng drawing. Mali ito. So, all of you in the design team should have, of course, the very basics of drawing na alam mo paano i-correct ang mga mali nila. And ikaw rin, pag pinoint out nila yung mali mo sa drawing mo, you will also understand, oo nga pala, mali pala to, sorry. Buti na lang na notice mo, hindi ko na notice. Parang ganon. Okay? Yeah.
Yan. Thank you so much po, ma'am. Thank you so much. I mean, ma'am, yung pala, yung pwede bang magkaroon kami ng parang brief parang knowledge regarding the difference nung ASME standard tsaka sa PSME standard?
Sa drawing?
Kasi opo, yes, in terms of drawing design.
In terms of technical drawing kasi, si ASME is not so much on that. Kasi yung technical drawing talaga will fall on ISO or ANSI, ANSI. So, dun kayo talagang magpa-follow to that. But know that hindi kasi yan yung main nyo. As a mechanical engineer, you're a designer, so you just have to know the specific areas kung paano nyo gawin yung mga technical drawings. Iba kasi kayo from drafter. Si drafter should know everything about technical drawing. Kasi you as an engineer doesn't mean kayo yung mag-create ng drawing. Hindi kayo talaga yung forever na maggagawa ng drawing. Because probably, you might be yung entry level nyo na job will involve the designing, magka-CAD pa kayo, whatsoever. But when you're already senior, pwedeng review na lang kayo, magtitingin na lang kayo, iba na yung magdodrawing. Or in the construction field, may drafter yan. And kayo yung magtitingin, kayo titingin ng drawing. Okay? So, probably, there might be cases na kayo yung designer, tapos i-draft nyo lang in paper, bigay nyo kay drafter, si drafter yung gagawa ng drawing, detailed drawing nyo. However, kung going back to mechanical, you will really have to know just the basic lang natin na needed for our job, which is yung mga diniscuss ko kanina and some other stuff na baka may hindi ako na-include. But if you want to look into standard dimensioning or standard drawing, technical drawing, you can look into the machinist handbook. No, are you familiar with the handbook, machinist handbook? And the ANSI standard, ISO standard, you can look into that. But I have to tell you, ang dami nun. So if you go to like the very source of resource reference book talaga, marami yun to take in, no? You have to reserve your brain cells to other information sa mechanical engineering pa eh. So you have to, cluster what is needed for you to learn on engineering drawing. And practical naman to. So if you just know how to apply it practically or in practical application, so you will never forget it. Hindi nyo kailangan i-review yung ganyan as long as it's practical application. Ayan, my question, so I'll just entertain this one. How much will be cost for price for a drawing? Actually, depende yan, no? My friend right now is a drafter and he drafts different engineering drawings. Depende na sa requirement yung mga clients niya, Yung cost niya is 1,000 per page. So that's something na you are going to create the drawing from scratch. Yung parang from scratch talaga, ikaw yung gagawa ng drawing and everything, blah, blah, blah. That's 1,000 per page. Okay? Say for example, may mga old designs, say mga 450 designs of 50 years old, na hindi pa, nakakamay pa yan, drawing pa yan nakakamay, tapos ipa-transcribe to like digital, which is CAD. So yung presyohan yan usually ranges from 750 pesos to 1,000 per page. Depende na kung medyo marami yung elements ng page. But it's customizable, depende sa nyo, sa client nyo. Okay. When it comes to drawing, for example, mechanical drawing, including na yan yung pag-design nyo ng mechanical drawing such as aircon, or FirePro, pag included na yung design, medyo mahal na yan. Okay. I once had a client, Dubai client, one condo unit lang talaga. And I was just asked to prepare for a technical drawing, plumbing drawing, and HVAC drawing, technical drawing niya. I was paid, was it $200 or $150? Something like that. So, but lang yun ang liit lang talaga ng square area nun. Tapos I just accepted the job like out of the blue. Sige, tanggapin ko, dinesign ko, very quick, like 1 day, 2 days, kasi may ibang work din ako. Like, immediately, nabigay ko yung requirement. Much design per sheet ang may bayad, and may bayad po ba ang revision? Revision is walang bayad. That's already, most of the time, included na talaga yung revision mo sa initial na payment mo. Kasi revision sometimes is just minor, no? Hindi naman siguro revision na sobrang, ang revision kasi, like, kung sobrang ang dami talaga niyan, like, change ang buong drawing, hindi na yan revision, that's entirely a new one. So you as a designer or a drafter later on, you will have to identify if the revision is just a revision or if it's entirely a new drawing to make. Because if it's entirely a new drawing to make, then that's another price. If it's just a minor revision or small change or something like that, it's just your client should not be paying for that. That's part of your scope of work. On standard practice, how do we need set drawing scale to 1:1? How about on very small parts in the opposite direction? Okay, scaling depends on you. What is needed or what is required on you to show. Okay, if your drawing sheet, just know this one that when you're in a drawing, what is the majority of the scale that you're using that will be placed on your sheet, and for those parts where you are specializing or specifically applying a different scale to that, you place in the scale as annotation below the view so that the reader will be able to know, okay, this is a different scale. But again, you can place in different scale as required in your drawing view. But if you're going to have the orthographic view, remember the orthographic view? front view, right side, and the top view. That should only be one scale if you are using a standard layout. One scale lang yan siya. Hindi siya pwede na yung front view nyo, ibang scale, yung right side view nyo, ibang scale, tsaka yung top view nyo, ibang scale. Hindi yan pwede. It should be on one scale only. Other views can be of different scale. Okay? And, sige. Maraming interested, no? Wow, thank you. Abutan ako na alas 10 dito. Ba't po ba required ang caps lock po ang letters sa drawing po? Okay, here's the thing. Why is it stipulated na all caps talaga or to say uppercase letter talaga in engineering drawing? Because in technical drawing, if you are going to use a small case letter, there are cases where small case letter are used as symbols. So if the symbols it will be mixed up to say, for example, to your technical, to the letters or to the words that you placed in your drawings, it might be misinterpreted if you use small case letter. Kasi, di ba si small case letter is different siya ng kaysa sa uppercase letter. So, I'm not pretty sure as to what's the basis of that kung bakit talaga. It's just that yan yung stipulated na mandatory requirement talaga ni technical drawing na caps uppercase aside from it being mixed up with small case letter being symbols, no. Yan yung alam ko. If you know one of them, there's the reason why, probably you can share it to us as well, but that's what I know as of now na hindi gumagamit ng small case letter because small case letters are sometimes associated with symbols or yung special symbols kumbaga sa mga variables. Okay? Mga variables, parang ganun. Pwede bang last na to? Sorry. Si JM Calales yung last kong do we need to be a PMA for us to approve or verify mechanical design? Okay, this is a very interesting question. Okay. Sa mechanical engineering dito sa Pilipinas, we have, di ba, ME, we have PME, Professional Mechanical Engineers. That is what the PME stands for. Yung PME, yung ME can still sign drawings, but there is a specific range of capacity of the mechanical design that you can only sign. If I'm not mistaken, registered mechanical engineers can only sign up to 2,000 kilowatts. Beyond that, si PME na. Kasi hindi na pwede si RME niya, si registered mechanical engineer. So, ganun lang. So, you have to identify first pag may magpapasign sa inyo. If that's only a generator set, genset for example, tapos yung capacity ni genset is just, say, 50 kilowatts. Makakasign ka ba? Yes. You're registered mechanical, makakasign ka kasi 50 kilowatts tapos yung nasa is 2,000 kilowatts. But you have to check the mechanical engineering code natin kasi I don't know the exact numbers, but there is a specific range kung hanggang kailan hanggang what capacity we can sign as a registered mechanical engineer. Beyond that, PME na yung kailangan. Okay? Okay, now, can we take freelancing job for designing? Yes, you can. Alam nyo ba na marami akong students right now that are taking freelancing jobs, 3D modeling jobs, that are already of good pay? Hindi naman sobrang malaki yung bayad, pero let's comparing to it's already a good source of part-time income. Just that how you can prove to your client lang na magaling kayo mag 3D model. Yun lang yun eh. Magaling kayo mag 3D model, how you can prove to your client that one. And when you start working already, and the client will see how good of a designer you are, how good a 3D modeler you are, then you will get more clients. And yes, you can take freelancing job. Kasi in the US, or in freelance platform, they don't need your license. They don't need your diploma. What they just need is your skills. If kaya nyo or alam nyo gawin yun. So if kaya nyo gawin yun, you get the job. If you perform consistently, you get a long-term job. Okay? All right. Sige. So I think that's all for the Q&A. Okay lang ba?
Yes po ma'am, thank you. Thank you so much. That was truly insightful discussion. Once again, we would like to thank you, our speaker, Engineering Marie Abanyo, for taking the time of her busy schedule to speak for this event. And with this, we would like to present to you the Certificate of Appreciation.
Okay.
Certificate of Participation is hereby given to Engineer Regine Mary Abanyo in recognition of your active participation and enthusiastic engagement as valued attendee at the JPSME National 2-day technical webinar. Your commitment to acknowledge advancement, thoughtful contributions, and eagerness to learn have enhanced the conversations and greatly aided in the event's success. Given with gratitude on 26th of November 2023, signed by Christine P. Calasara, the National Vice Representative for Visayas Cluster and Event Chairwoman of JPSME National, and Christian Lawrence T. Philomeno, yours truly, NCR Deputy and Event Co-Chairman and of the JPSME National, and Jan Abel R. Delizo, the National Chairman Representative of JPSME National. Thank you very much, ma'am. For giving us a wealth and knowledge about this topic, about mechanical engineering design drawing standards po.
Okay, you're welcome.
So ano guys, gising pa ba kayo? Mukhang ang dami parang ang interactive ng mga ano natin kanina, mga student. Parang engineering talaga, gising paggabi. Mga ganun talaga yung mga engineering students. So guys, before we end this, so kakatapos na ng our two guest speakers, let's have a raffle. And please comment #InnovateWithJPSME. Because you will have a chance to win a premium LinkedIn subscription, guys. So please type #InnovateWithJPSME. This talks na kape. Guys, go na, type nyo na guys. So, we will announce the winner ngayon na din, guys, para maano nyo na ang mga ano. Shoutout pala kay Orbanyo. Wala. Wala na. Go guys. Go guys, i-comment nyo na #InnovateWithJPSM. And guys, don't forget, before we end this, after the announcement of winner, there will be attendance for those attendees na nandito ngayon. So don't forget that. So let's wait after the announcement of winners. We will send it on our comment section. Ayun guys, sinend na yung attendance natin. So, wait lang. Pwede ba siya i-flash sa screen? Ayun. So, please fill out this form. So, ayun yung attendance natin. So, guys, paki-fill out para at least di kayo magkaroon ng problema with your certificate. Ayun na. So, yun, we have the first winner. 𝒕𝒖𝒕𝒔. Tama ba? So, I will list na lang yung name niya. Ayun. 𝒕𝒕𝒔, please comment down below. 𝒕𝒕𝒔, please comment para at least alam namin kung sino yung chat namin. Please comment hi. Comment hi, 𝒕𝒕𝒔. Bibilang ako ng 10 seconds pag wala, ma-invalid yung pagkapanalo mo. 10, 9, ayun. Nag-hi na siya. Hello. Ayun. So you will be posted on our FB page. Ayun, guys. Please message si National FB. Please message the National FB page ni JPSME National. 𝒕𝒕𝒔, paki-message po. And then, send the Kailangan pa ba na ng screenshot? Hindi. Kasi si CJ nag-hi na, wala pa na nanalo. Ayun, okay na. Na-screenshot na yung So,
official Facebook page ni JPSME National. Sorry, So, ayun, we will be giving one more premium link in subscription. So yun guys, continue commenting as I will now draw again. You have now 49 entries.
10.
Please comment hi para kung makita kayo immediately.
Yes, dun sa mananalo, please comment hi para at least ma-acknowledge namin. 𝒕𝒖𝒕𝒔. Tama ba? 𝒕𝒖𝒕𝒔. You're the lucky winner, 𝒕𝒖𝒕𝒔.
Para ma-acknowledge na nandito pa.
𝒕𝒖𝒕𝒔. Ayun, nag-hi na si 𝒕𝒖𝒕𝒔.
Yun ang hinahanap ko pa. Ayun siya.
Ayun, nag-hi na si Paul Christian.
Okay. So, please message yung official Facebook page ni JPSME National, and at the same time, I would like to remind you guys to please fill out the forms, as this will be the basis for your certificates natin. So, here is the form once again. Inap ko ulit. Ito siya.
I-fill up na lang po
Fill that
guys
out.
ang form natin.
Na po, pwede na po mag-stop ng comments. Bukas na naman po.
Guys, bukas naman guys. May mga raffles pa tayo. So, let's just wait for that. Kasi may next talk pa tayo about the AutoCAD basics naman. So, ayun. Just wait tomorrow. Ano siya? JPSME National ang name ng page po. Ayun, so everyone. So, ayun nga po. So, we will now end this webinar, the day 1 for our webinar. So, thank you everyone, to our guest speaker today, to our attendees, and to our committee na nandito, na tumulong at gumawa. So, see you tomorrow again. So, bye-bye guys. So, thank you everyone and God bless. Don't forget to fill up the G form para sa certificate. Thank you guys. Good night. Gawin nyo na yung mga backlogs. Bye-bye guys.